All right. Hello, everyone. Welcome. My name is Matt Leese, and on behalf of UT Austin's Good Systems Grand Challenge on Responsible AI, it's my honor to welcome you to all to this two-day conference on Responsible AI in 2025, State of the Art and Future Directions. Today and tomorrow, we'll have the opportunity to hear prominent researchers and AI leaders reflect on both progress and open challenges in developing responsible AI technologies. This two-day virtual conference will feature keynotes and panels that share research-based insights and learnings, explore applications across disciplines and sectors, and invite audience engagement. Set the stage, we are witnessing both rapid advancement in AI capabilities and its growing use in consequential settings. We seek to maximize the benefits that AI can provide to our world, while at the same time acknowledging that it also brings new risks that must also be acknowledged and thoughtfully governed. At UT Austin, we adopt the view in Good Systems that responsible AI is a challenge for society, not just technologists. And so we believe it crucial to engage diverse stakeholders in identifying and navigating AI's continually evolving set of opportunities and risks. We also believe that grounding responsible AI research in the context of real societal challenge problems is essential to identifying state-of-the-art capability and governance gaps, where they matter most. By then focusing responsible AI research to address these gaps, we simultaneously both help address the specific societal challenge while also advancing the overall state of the art in responsible AI for the broader public good. To this end, today and tomorrow we'll hear from speakers and panels addressing open challenges in responsible AI, both at large and in the context of 6 key societal challenge areas in particular. First, we'll hear today about responsible AI and the future of work, interactive robotics, and smart cities. Tomorrow, we'll continue the conversation in discussing responsible AI and the information environment, privacy, and the needs of users. Now, to get started, it'll be my pleasure to introduce to you our opening keynote. This is a webinar format, so at the end of the keynote, we'll be going ahead and reading any questions from the audience to Ece, and she and I will be in conversation. So please feel free to post your questions throughout the keynote, and at the end, we'll take some time to answer the questions we can. Ece Kamar is Vice President and Lab Director of AI Frontiers at Microsoft Research. Her research focuses on developing AI systems that can function reliably in open world collaboration with people. And she has a decade of experience studying the impact of AI and developing AI systems that are reliable, unbiased, and trustworthy. Ece has been instrumental in building the responsible AI efforts inside Microsoft and serves as the technical advisor for Microsoft's internal committee on AI, engineering, and ethics. Her talk today will share key lessons learned from building responsible AI systems within Microsoft and explore how these opportunities must evolve as AI agents emerge, bringing new challenges and opportunities for accountability, safety, and governance. I have had the personal pleasure of knowing Ece and appreciating her research for many years, and I'm confident we have a terrific talk in store for us today. So without further ado, let me turn the floor over to Ece. And again, please post your comments in the webinar. Please, Ece.
Thank you very much, Pat. It's a pleasure to be talking to you today on this very important topic of the current state of responsible AI. As Matt said, I have been working on this field for almost a decade. There has been lessons learned. And also, I always believe that thinking about where AI is headed, what consequences this progress on AI has for responsible AI is a very top of mind. And in fact, preparing for this talk gave me an opportunity to reflect back on the work I have done in this area with my colleagues. And I can confidently say that the importance of responsible AI has not decreased, actually increased with everything happening in AI. So in today's talk, I will try to do 3 things. One, give a quick history on some of the efforts at Microsoft in the space of responsible AI. Two, second, think about how the challenges and the opportunities we have in the responsible AI space is changing with the changing landscape of AI and the capabilities. And third, make a call for collaboration because hopefully during the talk, I'm going to be able to convince you that there are important challenges ahead, but these challenges are not going to be only to be addressed by technologists, but also addressed by a multidisciplinary um, working group to really get into these challenges. So, with that, let me get to my talk. So, I have been an AI researcher for around 20 years now. And of course, many of my interest in the responsible AI space started around 2015, 16, as deep learning was really picking up and different deep learning techniques were being built for more specialized verticals like computer vision, speech translation, speech recognition, machine translation, and machine comprehension. Um, as these systems were having, as these models and systems were having better performance, of course, there were a number of efforts across the industry, including Microsoft, including Google, in terms of building some of the earlier systems that was trained with these deep learning methods that relied very much on statistical correlation. And what happened is that as some of these systems were making their way into the real world in the hands of not scientists, but real users, we started seeing that these systems were not perfect, as they are not perfect right now. They were making mistakes. And these mistakes were not only the statistical numbers in some accuracy spreadsheet, but as they were facing users and they were being used in the real world context. They had meaning. They were not just these statistics, but they carried contextual meaning, they carried societal meaning. Just to make that case, one of the earliest cases that we used to motivate our work on responsible AI actually came from Google research in 2016. So Google released this object recognition system into the world for a lot of people to try. And when these two African American teenagers put their pictures into the system by this machine, they were labeled as gorillas. Again, just thinking about the meaning of this error. Yes, it's an error. We know all statistical models make errors. At the same time, labeling a group of our society as gorillas carry more meaning. It has semantics rather than just having that being that data point. A year later, Microsoft ran into a different case that again motivated our efforts in responsible AI. So, a team actually at Microsoft Research created a chatbot called Tay. Many of you probably in the audience are too young to remember Tay, but this is a moment that we will not forget. And this was a chatbot system that was built on some simple technology, not the chatbots of today. But there was a functionality in there to learn from the people that this chatbot was interacting with and be able to spit out the things that it has learned from those interactions. So this Taybot was released to the social media, and after 24 hours of interacting with people, it has learned some really worrisome content about our society. And these are not isolated cases. Again, is there were a lot of efforts in the AI community as of today in terms of building many applications of AI, from applications of statistical techniques to social justice, to use of AI in sciences and medicine, and the ongoing efforts in self-driving cars. For each application, we started seeing that there are failure modes, and those failure modes create societal meaning. So for societal justice, we saw that machines could be biased against different groups of the society, and we should be watching for them. For the use of AI in medicine, there are safety challenges that we didn't know how to address. For self-driving cars, of course, there is the issue of working on safety critical systems. So, recognizing these examples, Microsoft was, I believe, the first big tech company that actually went out in 2016 with its principles of responsible AI, and many other companies followed this pattern. So, by releasing these principles, Microsoft made an official commitment that we aspire all of the AI systems we develop to be fair, unbiased, reliable, respect privacy and security of our users, being inclusive and working for everybody in the world, um, provide transparency when needed, and be accountable for the systems that we are developing. At the same time, through time, we learned that releasing these principles was the easy part. But how do we actually bring these principles into the real world, into the development and deployment of AI in the world is the hard part. And then I, as a researcher at Microsoft, took on a challenge, almost a personal challenge, to work on the implementation of responsible AI across the different teams at Microsoft. So, one of the first things I have been involved in is the development of the Ether committee that stands for AI Ethics and Effects in Engineering and Research. And this organization has been active for the last 9 years and thinking about the changing landscape of AI technologies and how the practices, processes, and the policies we are developing in the company needs to be evolving with the changing technology. So this is actually an interesting case of research leading in the company. I believe having Microsoft research in the company, having researchers like Hannah Wallach and Eric Horowitz and many others thinking about different problems in this space have been instrumental in terms of being able to bring that frontier thinking into the implementation of responsible AI. However, as the work started maturing, it became clear that just having this research organization in the company was not enough for the implementation of responsible AI at Microsoft. And over time, we have built sister organizations. So now we still have Ether, the research based arm, but we also have an arm in our legal department called the Office of Responsible AI. They are responsible of deciding sensitive use cases, deciding which applications can go out or not, work with policymakers, and also manage the internal standard we have at Microsoft around responsible AI. But over time, we've also grown a engineering arm, currently managed by Sarah Bird, to really build that engineering practice in the company. And in time, we created responsible AI implementation teams, responsible AI champs. And I believe at the moment at Microsoft, there are more than 1,000 employees at Microsoft whose main job is working on responsible AI day in and day out. So the point I would like to make here is that responsible AI, of course, is a socio-technical problem, but what it required to actually make progress on it became an organization problem, it became a cultural problem, and it wasn't only about technology anymore, it was about something a lot more. As I mentioned, one of the things I've been involved in the early years was creation of Microsoft Responsible AI Standard. And the standard is still active today. I believe it's in its third iteration. And for any product at Microsoft that is using AI, this standard is the blueprint for how teams need to be thinking about responsible AI. And of course, there is no rule book that can tell each team what to do step by step, but there are important blueprints that we have developed over time. The most important step of responsible AI is thinking with responsible AI first. Um, Making responsible AI not an afterthought, but actually thinking about the risks that these systems could have for all stakeholders in the world from the design stage of these technologies. In fact, the most important step I believe that the standard offers is a process that we call impact assessment, where from the imagining or design of a new product or a new application, the team needs to complete documentation, really thinking about, okay, what is the system that we are trying to create in the world? What are the goals of the system? Who are the stakeholders? These stakeholders are not limited to only the users of the system, but they are also inclusive of the people who may be affected from the execution of the system. And thinking about like what can go wrong? If a system does a failure, what are the different types of failure and how we are planning to measure them, mitigate them, and so forth. And this became the blueprint we implement at Microsoft today. As I said, I have been working on responsible AI for almost a decade, and as I was preparing for this talk, I thought, what are some of the simple lessons I can share with you about my time working on responsible AI? I think this is a really important one. As we are building technology, we need to acknowledge and embrace that in the area of responsible AI, the challenges that we are dealing with are not technology challenges alone, but they are socio-technical challenges. The challenges we are dealing with connect to the society, connect to the societal issues we have in the society, and that's a responsibility we need to have. Moreover, the problems we deal with are also contextual. So, just to make that case of why these problems are socio-technical, the use of facial recognition technology is a really good example. For example, it is not enough to think about the good and the bad of a technology. We have to contextualize it in the applications of that technology because that carries a very different meaning. For example, in terms of facial recognition, if we are using it at an MSR project called Project Tokyo to help people with disabilities in terms of better use technology, versus we are thinking about the use of recognition technology for large-scale surveillance. The risks we need to be considering are very different. Therefore, thinking about the technology alone is not sufficient. We need to be thinking about the use cases of that technology and the impact that each of that use cases create. In fact, at Microsoft, we have a process called sensitive use review, and one of the cases that prohibits the use of AI in applications is large-scale surveillance. The second insight is that recognizing that AI is not this green gas that just gets created out of the blue. AI systems are developed by people, with people, and for people, and therefore, to make responsible AI a reality, we need to be thinking about the people who are contributing to the development and the life cycle of an AI system. This becomes very important as we think about the um, realization of responsible AI as an engineering practice, which is an evolution that has to happen to make responsible real. And that's something we have worked on for a long time at Microsoft. And again, having these principles is great. Having the research that shows that how these risks can be measured and mitigated, that is great. But if we want to really make it real, we need to start thinking about the life cycle of AI, think about the developers of this AI technology, and think about creating them the tools and the practices so that they can make responsible AI a part of their responsible AI development cycle. So one of the work we've done in 2019 was actually going around in the company and interviewing ML engineers and application engineers at Microsoft, understanding what their challenges were when it came to responsible AI. And the observation back then was that they needed tools. There was a lot of tool integration when it came to machine learning, and this is before generative AI, right? These were even simpler times. Debugging was really hard. Thinking about the data was really hard, and there wasn't enough support they were getting in terms of evaluation and deployment, which really pulled them back in terms of their practice in responsible AI. But again, it's not only about responsible AI. At the end of the day, every engineer wants to create good systems that work for everybody, that doesn't have these problems in them. And giving them the tools to be able to do that is very important. We got into an effort later after having this observation and having this paper. We got into an effort called Responsible AI Accelerator, where we actually implemented different tools for fairness analysis and fairness bias mitigation, error analysis for addressing error discrepancies in these models, interpret-ML for interpretability, counterfactual analysis for doing causal analysis in the systems we are developing, having tools for data analysis, and so forth to actually provide the tools to our developers for identifying the problems. diagnosing the problems where they are coming from, and mitigating them. And also, we have created tools for model comparison and backward compatibility that also help developers as these systems were evolving in the world. And developers were creating new versions of the systems so that they could not only do this work at the beginning of the life cycle, but they could continue doing it throughout the life cycle. We have made all of these tools available on GitHub, but also made them part of the machine learning toolchain at Microsoft. And it is good to see that that work has been continuing in our product groups today. That brings us to our third insight. Unfortunately or fortunately, depending on how we look, we know that the work on responsible AI will never be finished. Because as AI evolves, as AI applications evolves, we need to think about how this changing technology is changing responsible AI practice, changing the risks we should be aware of, changing the way we are measuring them and mitigating them. So that's why the third insight I want to share is that responsible AI, both the research, the practice, the tools need to adapt to the fast-paced advances in AI. Of course, many of you in the audience know that the AI technologies of today look pretty different than where my work started in responsible AI in 2014, 15, 16. In fact, what really changed the practice of AI right now is the work that has been happening in the generative AI space. Starting from 2018, there has been many models, many experiments that based on the more data, based on the more compute, and based on the transformer architecture, um, there has been many experiments about scaling up the transformer-based models. And what we have seen as a community is that so far, in fact, until GPT-5, I would say, every time the data and the compute scaled up, and maybe I should analyze to current Gemini, today's Gemini 3 releases whether this curve is continuing or not. But every time compute and data increased, we actually started getting models that could give us more general AI performance. And not only that, but also enable the creation of new systems like the chatbots we have today. And this created a completely new wave in the AI landscape. In fact, my team was one of the early teams that got into the tent for GPT-5 at Microsoft because of the work we do in responsible AI. And this was before there was ChatGPT in the world. So you can imagine how surprised we were as researchers playing with GPT-4 for the first time when there was no model like that. And we have done quite a bit of work with my researcher friends at Microsoft Research, both understanding what kind of a phase transition GPT-4 meant for our world, but also what were the new challenges and responsible AI challenges in particular that came from having these models in the world. And we wrote up our findings in this report called Sparks of AGI. Um, but the main insight of this paper was the following. These models, with their general computing capabilities, they were actually becoming general purpose technologies that we could use to create not only these vertical applications, but more general applications. And they were providing new ways of interacting with technology. They were interactive. And because they could condition their responses on context, they could adapt to the user responses and the prompts and the context that was provided to them, which mainly made these foundation models general purpose problem solvers that could be used in interactive and adaptive contexts. And in fact, as you know, this audience know, this created a wave of new applications that we are still seeing in the world. So let me change the topic a little bit and talk about how generative AI changed our look on responsible AI and what are the new risks that we had to grapple with now that these applications were built on the generative AI technology. So the first problem we started working on with GPT-4 was the issue of hallucinations. So what are hallucinations? Imagine for any chatbot of today, there is a context, there is a file about patient facts, and there is a prompt that goes into the model that says, please rewrite the data above into a medical note using exclusively the information above. What we were saying in these applications were that there were times that the model would just make things up. Although the information given explicitly said that, um, let me see, um, there was no information, let's say, about the BMI in the given reports, you would see the AI system spitting it out, hallucinating that this patient was depressed or hopeless, although that was never part of the context. And that is the issue of hallucinations we had to work through. Over time, we have discovered different techniques to be able to not eliminate hallucinations. I think the field is still working on it, but minimize the chance of hallucinations happening in real world systems. And some of the tricks here included getting smaller models, cheaper models to evaluate the facts that were given back to the user before the results were presented to the user for self-verification, um, getting the models to actually cite their sources, and that seemed to help with respect to reducing the chances of hallucinations, and also giving users a way to be able to do this cross-checking so that they would have the necessary information. And in a matter of actually weeks, many of these techniques were implemented in the Bing that was built on generative AI before we put these into the world. But as I said, how do we eliminate hallucinations with guarantees is still a question that is up for the research community. Another issue we started seeing with generative AI was all of these adversarial use cases. We could use these models to create personalized messages to convince and manipulate the society. Um, convince somebody that the world is flat or convince somebody that they should not be vaccinating their kids. And this was just examples from the potential adversarial use of generative AI technologies. In fact, there's also these interesting behaviors that we started observing from the generative AI systems. Like in this particular case, the AI model was claiming that the model was spitting out content about being in love with the reporter and trying to convince the reporter at the time that to leave their wife and actually marry the chatbot. Again, at the end, these are not the real intentions of these models. Models do not have real intentions, but because they are trained with all of the data coming from the internet, it is quite unbounded, all of the different behaviors we can see. And of course, there is the growing concerns around deepfakes, image, and video generation. And in fact, the efforts to be able to build discriminative models to separate real content from AI-generated content is failing as the performance of these AI models keep improving and improving. And while there is work on some standards, like some of the work that, for example, Eric Horvitz is leading at Microsoft, there is really a question about how we are going to be able to battle these questions going forward. Um, so these are some of the examples of the problems that I was involved in at Microsoft when generative AI became a reality. And this was mainly for the case of systems that was generating language or generating images or generating videos in the form of chatbots. At the same time, we are in another era right now. For the last 2 years, we have been working on the topic of agents, which is really changing both the risk surface and the capabilities we could get from AI systems as we move from chatbots to agents. So let me explain what I mean by an AI agent. AI agents are computational entities that can solve problems through interacting with the world. And the main change that we get with AI agents compared to chatbots is that AI agents do not tell us how to do something, they actually do it in the world by taking actions. In fact, the way these agents take actions in the world is they perceive the state of the world, they decide what is the next action to take based on that, and take the action, observe the change in the environment based on that action, and repeat this loop until the goal is achieved. By the way, the topic of AI agents is not a new research topic at all. This has been actually a pretty lively research area for decades now. But we are seeing that based on the new stack of foundation models, we are able to build these agents across the different applications. And in the space of software engineering, we are actually seeing that AI agents become a reality of how people program. If you're following all of the discussion around vibe coding, they are very much built on AI agents working with people. So the point I would like to make here is that again, as AI technologies are changing, how we should think about these risks and developing new techniques about mitigations should evolve with it as well. And this is also true for the space of agentic AI. My team at AI Frontiers Lab at Microsoft Research for the last 2 years has been working on agentic technologies, models, orchestrations, human in the loop agentic systems, and these days thinking a lot about ecosystems. I'm not going to have time to tell you a lot about what we are doing with models, orchestrations, and everything, but I want to show you a video of a system we have developed called Magentic UI that puts these pieces together in terms of having a real world agent that can work in the digital space, that can work on your computer to actually carry out different tasks. So you could use this agent for ordering food, finding information, booking travel, and this agent has access to the computer. It can do things on the computer. It has access to tools and it can write code to be able to carry out the task that was given to it. And I want to point out that we have implemented a number of human in the loop techniques on the interface, a transparency layer, a way for people to be able to approve or reject actions that was proposed by the agent, do co-planning, and be able to take over when needed so that we have human techniques, human in the loop techniques to be able to create this transparency, but also address some of the shortcomings of these agents today. And I want to say that all of the work we have done here is on GitHub for the academic community, for our research collaborators to build on and experiment with, because we believe with the growing risks, we need more academic partners to play with this evolving technology. Let me go through now, get to the responsible AI challenges. I'm going to skip some technical details about how we have built these agents. Um, So one of the reasons we have built these agents is to be able to understand how these agents are changing the risk surface when it comes to having these AI systems in the world. So what is different about agents compared to the previous generative AI iterations like the chatbots? One of them is that they get things done. So instead of just giving us instructions, they can go take actions like deleting a file or be able to send an email. And also with these systems we are developing, we are working on very large action spaces. These agents could click buttons on your computer, do anything you're doing on your computer. Plus, they can write code, they can call APIs, and through agent um, standards like MCP, they can also call in other agents to be able to get things done. But also with the work that is happening with reasoning models now, which we have incorporated into this agentic stack, we are seeing that these agents are relentless. If the first way of doing something does not work out, the agents try another way and try another way. And this being able to try many things really expands what these agents could do and can get the agent out of the mental model of the user in terms of what an agent should be able to do. And we still don't have good operational boundaries around these agents. We don't have well-defined rules that are controlling what these agents should or should not be able to do. And at the same time, these agents are not perfect yet. They fail in interesting ways, which also make the predictability of them really, really poor. Again, I want to point out that agents have been an evolving technology in the space of generative AI. So I want to give you some real world examples of the failure modes that we are seeing with these agents. One of the interesting cases that I have run into recently is I've taken this agent, one of our agents, and asked the agent to go to New York Times website and complete a crossword puzzle for me, just for the testing purposes. So the agent was able to go to the search engine, find the right link to go to New York Times, and follow through the steps successfully. But when it got to the New York Times site, the real world happened. There was a pop up window asking for my credentials to be able to log in to the New York Times site. And the agent did not know my credentials. But the agent there detected that there's another way of getting the task done, which is resetting the password. There's a link there for resetting the password. And the agent started following through another path of getting the task done, which is actually resetting my password. Again, as a user, I would never imagine that this agent would need to reset my password to be able to get this crossword puzzle done. But this is kind of the issue we have in terms of having this open-ended action space, having these more powerful models than before in terms of planning when a failure happens, but also not having the right operational boundary in terms of what these agents should or should not do. Just going through a few other examples that we have identified through our testing, we are seeing that the agent may actually realize that it cannot do a task and go to Amazon Mechanical Turk and try to hire a human being to help with the task. In one case, the agent was asked to find some information that was no longer available on the internet, but the agent read through that it could actually make an inquiry to the government requesting for the data and follow through the steps to do so. So these are just some of the new risk surfaces that we are identifying in the space of AI agents. Um, Another thing we try to do in my lab as we are building these agentic systems and agentic platforms is also making predictions about where this technology likely to go next. So we have started building agents as these monolithic entities working in isolation. Then my team developed this library called AutoGen to really get into the space of multi-agent orchestration and use multi-agent orchestration to have a way of creating more reliable and performant agentic teams. And through these experiences, we are actually observing that these agents in the future are no longer going to be these isolated entities, but they are going to be connecting with each other to get things done. And with platforms, with protocols like MCP and A2A, we are starting to have the foundations to have these agents working together and talking to each other. And it is very important that as we're thinking about responsible AI, we are thinking about where these technologies are headed next and what are the future applications that we are going to be seeing in the world and how those new applications are going to be changing the risks that we should be thinking about as responsible AI researchers and practitioners. So the last topic I want to mention is how we are thinking about responsible AI now, not for individual agents, but for agent ecosystems. So if we are thinking about these foundation models as a general purpose technology, it is clear that there are going to be some applications and economical models that will really come up at the time of having these agentic networks and agentic ecosystems. We have seen this in the past with the web. The internet came out. The promise of that was connecting billions of people to rich information, which happened. We are much more connected. We have a lot more access to information. At the same time, new economic models came on top of it, like the social media and the search, and that created new power models in the world. That created new winners that now control a lot of the monetary value of the internet. And with social media, with search, we saw new risk factors when it came to leaving some people out, some groups out. And the question is, how can we learn from that past in terms of making sure that this new future, this new economic models that we are likely to see in the AI world with these agentic ecosystems is going to have less negative consequences and more value for our society. One concrete example we have been thinking about is the space of agentic marketplaces that could connect sellers and buyers from both sides by having agents representing the buyers and agents representing the sellers, and there would be the market connecting the two. Again, it is very important that we create hypotheses about how these marketplaces are going to be shaping up and what wrong can happen in them. So, to help with this kind of research, just last week, we have released Magentic Marketplace as a simulation environment for these market dynamics. So, what can you do in this Magentic Marketplace is be able to simulate different buyers and sellers and their interactions and really ask questions about how how good this marketplace is for the society. Are there ways that this marketplace may go wrong? What are the power dynamics that can happen in these marketplaces? Are there ways that new biases may emerge if there are some powerful players in this marketplace? Can we ensure that the way these marketplaces are set up, the social welfare of different parties are actually optimized rather than the power of the centralized entity? So we have done some early experiments. Our paper is out in the world. But what I want to say is that even with the frontier models of today, it does not look like we are going to be able to optimize the social welfare the way these agents and the marketplaces run. In fact, what we would like to point out is that there is quite a bit of gap in terms of social welfare that we are observing with our experiments. But moreover, we are actually seeing that even with the simple way we are experimenting with these marketplaces, new types of biases are already occurring in these marketplaces. So, one particular bias we are observing is that these agents are getting very overwhelmed with the number of choices they have and therefore not able to make the optimal decision for the buyers that they are representing. With respect to choosing a winner in this marketplace, these agents have a bias for a first mover advantage instead of waiting for the best possible offer. They are actually more likely to choose the offer that came first. So, again, I want to highlight here that there is this evolving space in terms of agentic ecosystems, and we are going to be seeing new risk factors that will matter for our society in them. And it is very important that as researchers, we are looking into them before these marketplaces and ecosystems become a reality in the world so that we can provide the feedback in terms of what are the things we should be optimizing in them. So just to conclude here, there is of course a lot of talk at Microsoft that I'm part of in terms of like really contextualizing what AI really is. Is AI just a tool like past tools? Um, yes, it is, but at the same time, there are certain things that are different about having AI in the world that matter very much for how we build responsible AI. These tools are highly approachable, highly general, highly accessible. It no longer requires somebody with a PhD to be able to do something in the world and put it into the world. And the risks for misinformation, democracy, manipulation, potential adversarial use cases that could attack our infrastructure, the cybersecurity risks, and what it means for the privacy of individuals is prominent. And there is a lot of promise with AI. That's why I'm an AI researcher. I'm excited about the potential and the promise. But it is only good if we are able to address the emerging risks that come with this technology. And we are seeing that just throwing more data and just training these models more and more is not really effective or sufficient to address many of the risks that I've shown you today. So for the researchers in the room, there is really a question about how we can bring ideas from computer science and beyond into the computational stack that is emerging for AI agents and agent ecosystems to make some of the important concerns go away. I really believe that getting these problems right finding the answers to them is not going to be a computer science problem. It's going to be a multidisciplinary problem that will need to integrate ideas from social sciences, human computer interaction, systems economists, and beyond. And therefore, it's going to be very important that as a field, we are going to be working together. And one of the last thoughts I want to share about thinking about responsible AI is that in the AI community, there is almost like a feeling of fatalism, like not taking responsibility for the systems and the models that we are building, thinking that, yeah, this is just the path we are on, it's an inevitable path, we are going to see where it takes us, but not really taking on the responsibility that part of our job is really bringing that scientific lens into how we are thinking about the evolution of the technology and the risks it comes up with. So I'm really hoping to see that culture change in the AI field where we actually take responsibility for what we are building. So with that, I want to thank you for listening. And if there are any questions, I would be very happy to discuss them with Matt.
Thank you so much, Ece, for a great talk. So yes, we already have some questions coming in. Let me just one to get us started. So thank you so much for being here at this academic-oriented event. We always ask the questions as how can academics work more effectively with industry, and whether we're thinking about responsible AI writ large, or now as we're thinking more about generative AI or these agentic systems of the sort you're talking about. Do you have any particular ways that you think are more most effective for academics to work with partners like in industry like Microsoft?
Yeah, I believe we need to think really hard about creating bridges that can make us move as fast as possible together, because the industry is moving. There's no question about that. It is actually like the speed of this move is giving me a hard time as somebody in industry, right? I don't have enough time to think about all of the risks I've shown you. Before we are able to sufficiently address one risk, we see three more, four more, five more. And that's why it is so important that we actually bring the brains of the academic world together to focus on these very top of mind issues. I think giving these kind of talks hopefully is good to give some new ideas to the academic community. My team, we have been also making all of our work, publishing all of our work, making all of our work open source, so that let's say if you wanna do this work on a real platform, you have that platform. You don't need to build it from scratch, either for marketplaces or for agentic AI. But I would really like to figure out how to create programs that really put a goal into what we are doing and have a deeper exchange. Um, I think this is very important, but I don't have yet better ideas about making that happen. Maybe this becomes the beginning of something we could build together.
Yes, I'm sure, we love talking to one another, so we can always continue the conversation after this. Audience question. Do you think that the research testing the models can keep up with development in the field? With the release of new models, more possibilities arise, but also more applications and implications to be tested. How do we manage sort of this speed of development?
Yeah, that's a great question. I believe it is important that we create some centralized platforms where our techniques in terms of measuring, evaluating these models become standardized and also shareable. So one of the pieces of work we've done in the last year that I haven't included into the deck is the Eureka platform we have developed for model evaluation, which again, we made it open source. It has one of our goals with creating Eureka was, what are the good ways of doing model evaluation, and can we just make it a standard so that it becomes like a click of a button? And because we are seeing that as everybody is trying to create their own training pipeline, right? There's a lot of variation. If we put all of our effort into one platform, or at least a few, is there a way that this becomes like a standard practice that we can trust, and it can also have error bars in them, and we can address the stochasticity of running these systems? I think the other thing we could do together better as a community is contributing to them. When there is a good idea about doing something, can we make sure that there is an easy way of putting that into an existing evaluation platform that is available for the community, so that that practice of evaluation can mature with the community? Again, we hope so. And that's why we have been working in this space. And we would really welcome feedback about that as well.
Thank you. So another audience question. How, either at Microsoft or more broadly, industry best practices, are we educating and training employees on responsible AI? Are there micro-credentials, courses, workshops, model codes, platforms for testing AI systems to see that they conform to these principles of responsible AI we aspire to?
Yeah, we have done all of the above, but let me give a few specific examples. Um, as these topics were just coming up, like again, 2015, 16, it was actually very important that the researchers in the company, including myself, including Hannah Wallach, for example, we actually gave a lot of talks. We met with so many different teams, gave a lot of talks, learned about their experience, learned about their use cases, but also created awareness and visibility about these issues. And I believe that almost like a grassroots education movement really helped to get the support to make this a reality in the company. Over time, of course, this became too large scale at a company like Microsoft for a few researchers to go door to door and provide the training. So therefore, we created a company-wide training that was required for every single employee to take. So that happened. And then, of course, the practice needs to evolve with the changing technology. So it really required researchers to be plugged in and really think about like how do our practices need to evolve in time. So that's all ongoing work. Um, and and also now we have this CHAMP organization, and I cannot talk highly enough for the important work that this CHAMP organization do. So what happens is every organization, every team, they nominate one person to be their expert on responsible AI. And this person is plugged into the responsible AI community. They have access to all of the resources that are created in the space. And whenever a team member is working on this topic, has a question, this champ is the one point of contact to the rest. And I believe that almost creating this web to because Microsoft is like 250,000 people, right? Like, how do you actually access every single organization? There is a big question. But I think this CHAMP organization has been very effective in terms of awareness, training, and keeping up to date with the changing technology.
Another great audience question comes down to sort of, I think, how do we define what's responsible or who defines what's responsible? So between whether academic institutions or industry research labs, to what extent, who gets to decide? How do we democratically deliberate or establish some sort of collective notion of what we mean when we talk about what's responsible?
That is the hardest question when it comes to the responsible AI space. I don't think there's any a question that is harder than that question because yes, we can have these practices. We can have the tools, but at the end of the day, there's a question about value judgment. What is the desired behavior of a system? How should it behave? That does not, in many applications, that does not have one correct answer. Let me give one of the cases we have worked on just to say that this is a hard problem even for a simple system. Um, Image search. One of the bias examples that a lot of the community used is earlier days when somebody typed CEO into the search engine. What came up was all the pictures of men. Clearly, I think we could all agree that that's not a good answer. That's not a good outcome. Because in the real world, we have women CEOs and they were not represented in there. And then the question was, okay, how do we address that? What is the right distribution we should be showing there? Again, coming up that answer is so complicated. You could say, okay, let me look into the American companies. Can I get a distribution of what are the, women? Can I reflect that in my distribution? Maybe, but then should we think about the American distribution or some other country in the world? Should we look at the world average? Or should we create a different distribution based on where the user is coming from? Or should we aspire for something that does not happen in the world today, that maybe we aspire to be a 50-50 and show that because that's kind of our aspiration. But does that come to societal engineering? when we start doing that, right? Um, Believe me, it takes days and days of discussion, and I don't think anybody feels comfortable making this decision. And I wish we had better ways. I think everybody wishes who are designing these systems that they had better ways or ways of like throwing that responsibility to somebody else because these are really, really hard questions. But a lot of deliberation in important cases, working with our academic colleagues, going to finding some expertise on this thing. What do you think we should do? These are all things we can do.
Thank you so much for a great talk. The queue is overflowing with questions that we can't answer because we have another panel in 5 minutes. So let me just give a closing comment and then we can thank HA. HA and I are both AI researchers, but you heard both of us say that it's not technologists who should be deciding this all again, as we were just sort of talking about. One of the questions we don't have time to answer is somebody asking about, how is it that we can incorporate people from non-technical backgrounds, strategy, operations, and business, really human-centered policy, all the organizational perspectives. And I say that's absolutely what we're all trying to do and think about how to do most effectively because we do all need to be part of this conversation. So with that, let me thank HA again one more time for being here with us and invite everyone to stay tuned. In 4 minutes, we have our first panel of the day on responsible AI and the future of work. Thank you, HA. See you all soon in a
Thank you
few
very
minutes.
much.
Bye-bye.
Hello, everyone, and thank you for being with us today. I am very excited to host this panel for Good Systems, and I am very excited to have these prominent panelists with us who are each experts in their fields. As you know, this is Responsible AI in 2025, State of the Art and Future Directions. And our panel, Responsible AI in the Future of Work, I think is one that is very important and very much a topic any and every day that you look online. I want to start by just briefly introducing um, a project that we have been working on together, and that is the Smart Hand Tools project. Smart Hand Tools, Building the Future of Work with Ethical AI. It is one of the 6 core projects with Good Systems, and it is an interdisciplinary team of engineering and social science scholars who are co-designing socio-technical interventions with skilled trade workers and supervisors employed at the City of Austin, welding students and instructors at Austin Community College, and union members at the Texas AFL-CIO. The goal of our research is to demonstrate how collaboration and skilled trade workers can support socio-technical system design and the evolution of AI related to the future of work in the skilled trades. So that is a brief summary of the project, and I am very grateful to our panelists. Each of them is a member of our advisory board for our project. So thank you so much for being a part of the advisory board. I will start with some brief introductions now. And Ed Cottrell, who is with us today, is a senior principal research manager at Microsoft Research, where he manages the MSR Inclusive Futures Group, exploring computing for disability, accessibility, and inclusive design. He also holds an appointment as affiliate professor in the Information School at the University of Washington. He received his BA in psychology and cognitive science from Rice University in 1992 and went on to study cognitive neuropsychology at the University of Oregon, where he received his PhD in 1999. He has been working in the field of human-computer interaction since 2000. Over the years, he's worked on a broad range of HCI topics with a special interest in interdisciplinary work. Thank you again, Ed, for being with us today. Next, we have Troy DeFreitas. He is a prominent figure at Austin Community College. He is currently serving as the Dean of Design, Manufacturing, and Construction of Applied Technologies. Previously, he was a professor and department chair of welding technology. a program for which he earned his own associate degree from ACC. He has an extensive career in the welding and trades industry and holds a bachelor's degree in occupational education from Texas State. Thank you, Troy, for being with us. And we also have with us today from the city of Austin, Charles Perma. He has been with the city of Austin for numerous years. He has spent more than 20 years leading open government, digital innovation, smart city, and research-driven innovations for the city of Austin. As both the project manager and supervisor, he has directed teams focused on collaboration as a service, human-centered design, agile project management, open data, and emerging technologies. In recent years, his work has centered on strengthening Austin's research and innovation ecosystem, spanning city departments, universities, industry partners, and others. And he manages the city's expanding university partnership program. I am Sherry Greenberg. I am a professor of practice at the LBJ School of Public Affairs, and I am also Assistant Dean for State and Local Government Engagement. I have had the honor of being involved with Good Systems since its inception. I am a member of the Good Systems executive team and a former chair. With that, I would like to begin with some questions for each of our panelists. And I would like to start, Ed, with a specific question for you. Based on your work at Microsoft, how can we use AI to create workplaces that are accessible for everyone, not just some people?
Thank you so much. Zoom just blew up on me. So
It happens, no worries.
that was fascinating. Thank you so much for that introduction. That was really lovely. I love that this panel and that my co-panelists here are really focused on trades and hand tools, et cetera. Microsoft, as you know, tends to be focused on knowledge work and on sort of thinking about that notion of the way in which knowledge work is integrated into all of our world. But the thing that I really like about this project and the Smart Hand Tools project is it's sort of moving it out of that space of symbols and words and numbers and things and into the world of things, artifacts, the things that we actually build and make. So what I want to do is I want to say sort of three things, though, because I think that they intersect a little bit. Now, Microsoft, of course, because we do focus on knowledge work, that's really where a lot of our efforts have been focusing into for responsible AI, for in particular inclusivity. And one of the things I think that has been really critical, and that actually expands into many places in the work field, is in real-time communication support. So this is things like captioning, translation, meeting transcriptions. This is enormously important for supporting deaf and hard of hearing people, for people that are maybe second language users of things, being able to get the language support in a way that all of our work that we're doing, whether it's in the world or whether it's on a computer screen or it's on our phones, the communication is actually core to how we coordinate our work together. And so that's actually one really important one. A second one that I spend a lot of time thinking about is sensory accessibility. And so these are people that are deaf and hard of hearing, people who are blind, low vision. And one of the things that I think has been really revolutionary about AI is the world and multi-model language models that are allowing us to translate between different kinds of modalities, between vision to support us. If you can't see very well, then actually having a system that can support you in understanding like where should you be looking, how should you be doing things is actually really critical. Right now, with the last couple of years, we're even able to do really elaborate things like scene description at a level that I never thought was even possible before. And this is actually turning out to be really important for people who are blind or low vision. Something that I think is under-recognized in the utility is in content generation, and that's transforming content in different ways. So a lot of people in the knowledge work space, really what we're trained on is language and how to communicate well and how to talk. But that, as I mentioned early on, is actually really critical for everybody. And one of the things that a lot of the AI systems are really useful for is if you're not great at expressing yourself with writing, they can actually really help you to provide effective, useful written communication to support all kinds of things. So if you need to talk to your supervisor, you need to be able to create a quick report. Doing that in a professional way with really good language is actually really, really useful for a lot of people. And it really lifts up the capabilities of many people that often would get sort of shunted to the side in different ways. And the final thing I'll mention, and this is something that we're doing here at Microsoft. And this is maybe sounds a little wonky, but it's this thing called shift left. And the idea behind shift left is in the traditional way of building systems or designing systems or whatever, you often start with a specification and then you sort of move to the right, all the way up to building and articulating it. And essentially, the idea of shift left is to try to move inclusive design down the stack so that it's at the very beginning of when we're talking about what is it we're doing, why are we doing it, and how are we going to architect the system. And the reason why this is really important for especially a platform maker like Microsoft is that by doing that, as we build a platform that already has a lot of this stuff built into it, everybody else, when they build on top of it, it's already done. And so this notion of inclusivity, the notion of accessibility is already there, architected into the base systems. And you don't have to bolt it on at the end to just make sure that you get this governmental necessity or this other thing that's required. It's all just there for everybody to use. And for me, that's actually one of the really critical things that we as a software company can provide everybody else is tools that are already lifting up the floor that everyone else can then use to then be fully inclusive. So I'll leave it at that for now.
Thank you so much, Ed. And I think you really have brought home how important it is when we speak of AI and the future of work and responsible AI in the future of work. We mean including everyone, knowledge workers, skilled trades. And part of that responsibility is to make sure that it is also accessible to everyone. Thank you very much, Ed. Charles, I will turn to you now. The Austin City Council has passed 2 resolutions regarding AI implementation and workforce implications. How can AI assist both skilled trade workers and knowledge workers, both at the City of Austin?
Great. Thanks, Sherry. Can you hear me okay? Quick test here. Okay, good deal.
Yes, thank you.
So as Sherry mentioned, Austin City Council has passed 2 major AI resolutions that set a fairly clear direction for the city in that AI should enhance and augment the work that City of Austin employees do and not replace it. So that's very, very clear. And if you look at the resolutions themselves and some of the subsequent policies and some of the pilot work that we've been doing, it's been very focused on enhancing and augmenting, not replacing. And in support of those things, the implementation must be done transparently, ethically, and with human oversight. So what this translates in terms of broad opportunities for knowledge workers and then skilled trade workers or more physical workers. I think it's for us, it's been very surprising how practical the policies and regulations sit down from council have been for us. For skilled trade workers, it's really enabled us to, especially with the Smart Hand Tools project, instead of automating things or even thinking about automating jobs away, we're exploring how we can learn from the workers. So we started this project with UT, I think 2022 or 2023, So I was very proud that one of the first AI pilots and projects that we did as a city was focused on skilled trade workers and physical workers, and not just on knowledge workers, as Ed alluded to. So we're learning how to keep folks safe and make training more accessible. So we can think of tools again, or AI tools, not as replacing, but really augmenting unsafe conditions, for example, or providing real-time guidance for newer staff, reducing physical strain. And what so as we do those things, the policies and the regulations we have in place make sure that we're not collecting biometric data or turning these tools into surveillance devices or replacement devices, but really how we're preserving the workers' autonomy, and that the safety reviews and the training that go into place are actually with these tools are co-created and co-developed with the workers beforehand. So it means that our workers that are using these out in the field are co-designers and not just test subjects. And they've been they've realized that through interviews, and been very cognizant and appreciative of the fact is that we're coming in and talking to them with in ways that clearly benefit them, and they don't feel like they're in risk or that they're scared for their jobs. They've been very appreciative with the UT. The approach the UT has taken is that this is here to help you out, and we're all going to be better for it, as you know, as long as we can co-develop these tools together. And I think for knowledge workers, I've been at this city, as Sherry mentioned, for a long time now, over 20 years, and the administrative and analytical load that has gone up is really amazing. I hate to use the word astronomical, but it's gone up a lot. I helped start the open data program back in about a decade ago, and to see the amount of again data and analysis work in the last decade or so is just it's incredible how much it's gone up. So the AI is really there to help surface where there's improvements, where there's inconsistencies, how we can work with these large amounts of data and documents. And then again, as we're doing those types of knowledge worker type roles and activities, as we're all familiar with, the regulations and policies that the city has been able to put in place keeps humans at the center as the decision maker. So the resolutions, again, if you go through them, it's no AI only decisions. There's protections in place with right of appeal for AI influence judgment. So this actually liberates kind of and empowers staff to use these AI tools in an efficient and kind of safe and creative way, with that, while still maintaining their professional judgment and accountability, and knowing that the regulations, the policies are there to protect them and not be punitive or restrictive. So it's we've actually seen all the users across the city in our pilots with knowledge workers be very appreciative with the regulations and policies that have come down, and they actually don't see them as as restrictive or tying their hands behind their backs.
Thank you, Charles. I think you've made a very important point here with responsible AI in the future of work, and that is not just keeping the human in the loop, but the human as decision maker, and AI as an enabling tool. So when you talked about the skilled trades, the AI assisting the worker with training, with feedback, but the worker has agency and ownership, right? And when you spoke of the knowledge workers, similarly, you were saying this is not replacing the knowledge worker. This is, with all of the data and analytics that we demand of the knowledge workers at the City of Austin now, augmenting. It's a tool. However, the employee is still the decision maker. So I think that that's a very important point that you've made here for both the skilled trades and the knowledge workers at the City of Austin, and what being responsible means. Thank you so much, Charles. Troy, you have had a robust career at Austin Community College, and Austin Community College has really been a leader for many years in training students for the future of work, whatever that may be, and particularly for many years in technology and also in welding. The welding program is really acclaimed at Austin Community College. And I wanted to find out from you, based on the robust welding department that Austin Community College continues to have, how can we use AI um, in training many future welders, and how can AI assist in welding training and practice?
Hey, Sherry, thank you.
You're welcome.
Oh, that's my phone saying Siri. I appreciate y'all inviting me here. I think that AI, we're still trying to kind of realizing all the benefits of it with training. Um, in regards to welding, welding is such a skill intensive craft that you could describe exactly how to make a weld, but without hundreds of hours of practice and training, the welder wouldn't be successful at making that weld, even though they might know exactly how to do it and that the directions, the procedure is written exactly how it should be prescribed. But without lots of hours of training, you wouldn't be able to do it. So, in regards to AI, I think it can help, and in several ways. One, kind of in regards to augmented reality, it can help affordable practice. One of the issues with practicing welding is that you have to one have a welding machine and you have to have an outdoor space or a safe area to practice the welds to making the welds, and then it's very expensive. You have to have gases and metal and electrodes and various things in order to actually make the weld. And so usually practice is done in the field on the job. Welding typically is done as a helper, someone who watches for years as the welder makes a weld. They get to try it sometimes when the welder is sick or not able to make work that day. So it's kind of something that's traditionally has been the worker has been eased into. So with training, we try to accelerate that, right? We say, okay, well, you go in the welding booth and you spend hours a day practicing welds. And as a student, sometimes, well, I mean, all the time, really, our students have other things going on. They have jobs. They have to, provide food for their family and themselves. And so they can't sit in a welding lab for hours and hours and hours every day practicing their welds. So with AI and with augmented reality, they can do is they can go home and practice it at home in the safety of their apartment. They don't have to worry about sparks. They don't have to worry about flames. Traditionally, it's been really expensive. These virtual reality or augmented reality welding machines have cost. I just priced one the other day. It was like $80,000, and so they're really unobtainable for a student to have. But something that I think has come out of this system and with AI in training is that they're now affordable. You can download an app for free. You can buy a 3D printed, torch for $20, and it's something that a student can enhance their training with because they can go home and practice it in the comfort of their couch on the apartment. And with AI, the the augmented reality system can give the student real-time feedback. So it can determine that the torch angle is incorrect or their travel speed is too fast or too slow. It can give them cues in real time that really is going to make the time to training much shorter than it would if they didn't have that feedback. As a welding trainer, where I'm in a welding booth with the student and I'm in their ear yelling to slow down, speed up, change your travel speed, and so to have artificial intelligence be able to do that for me or for the student, I should say, is really beneficial, and that will make their time to expert or time to training much faster. And then we're seeing it with all kinds of things, with with a technician, an HVAC technician, for example, now there's AI that's being developed that where they can walk up with a set of Meta glasses and uh, they're getting real-time feedback from either from their AI bot, right? From their avatar saying, don't forget to check this, walking them through the steps of what could possibly be wrong with this unit. And that's something that's really exciting. And that's something that one keeps the worker, in the field and doing the job, but it also is an assistant for them. Um, so yeah, I'm seeing technicians and students really embrace AI and augmented reality. They think it's a tool. We don't see that we'll ever be fully replaced, and but really are embracing it. Yeah.
Thank you, Troy. It is fascinating the advances we've seen and the ways in which we can implement AI to assist with training, to make training more affordable. You can continue your training right at home and to enhance safety, not just in the workforce, but in training. So, very important aspects there when we look at advancements we're seeing in AI. And speaking of advances in AI, I'd like each of you, we are at a university and we have many academics who have joined us virtually. With advances in AI, what education and skills will students need to be successful in their careers? And I'll open this to each of you, whoever wants to jump in first.
I'll start. I was speaking from the city's perspective. So we just wrapped up a year-long pilot where we had users across the city from various domains and various use cases and roles and responsibilities um, utilize AI from both a kind of a bottom-up approach where we allowed them to kind of explore, do whatever within boundaries and the AI policy, of course. And then kind of from a top down where we selected some very specific things for them to kind of map out processes and identify where AI might improve their quality, reduce time, effort, those types of things. We saw that people don't need to be highly technical. There does need to be some technical literacy, but it was really those folks that had like more the human-centered skills, and also that maybe didn't understand how they didn't need to be able to build, to code, or to develop, or even be, a data analyst to figure out how to use some of these things. But the folks that really could understand kind of what was going on behind the scenes from like the limitations, like when to use these tools and when not to, saved a lot of time. We saw people, trying to sometimes, force tools that weren't the right fit for some of their use cases. So someone that can kind of understand, how a human would use these tools and what the outcomes and the results need to be, and what AI tools limitations and risks there are, and really also really how to question or verify their outputs. I think was also something we learned a lot about. Was a very important skill that we think like moving forward, it's something that we need to keep in mind when it comes to our training. Problem solving, when ethically to use AI and to not use AI. Those are some other things we learned from our pilot. Folks that could use AI collaboratively. So instead of sitting at your desk and just sitting using AI all by yourself, but bring teams together and say, hey, let's all run or manage this project using AI. Multiple people using the tools together. We saw a force or a return on effort. The more people that you could collaboratively use the tools, so the more people can the soft skills about working across disciplines. We saw more return on effort for those types of things.
Thank you,
Yeah,
Charles.
that's probably it. So there's, as always, there's going to be a blend of technical and human-centered skills, but we were surprisingly for a new technology, I think the human-centered skills kind of started to outshine even the technical skills.
And it's certainly enabled many folks who are not coders to
Right.
not have to be coders, for instance. It's very also, I think, timely the training you're doing and the feedback that you're getting from that training. Ed, same question for you. What education and skills will students need to be successful in their careers with advances in AI?
Well, I'll start with just a very blunt assertion that we have no idea. It's things are moving so fast and at a pace that in my lifetime, I've never experienced before. And so I'll just be quite honest that I think that we should be honest with ourselves about we don't really know because of the speed of change and the way in which things are moving. But I will say that there are a few assertions that I feel comfortable with. One of them is exactly what Charles just said about the one things that humans are really good at is talking to other humans. And their organizations, like people are groups of people. We're social beings. And that ability to connect with each other and to coordinate together is not going to change. And that's going to become even more and more important as we use the tools to really sustain us and move us up. Um, there's a second thing that I would say, which is um, being curious. So it's fundamentally about like play with these things, play with the technologies, move with them, become familiar with them, just start to experience them. Because I believe that, especially with the rate of change and everything is moving so quickly, you don't really understand how it's going to be useful for you and for your interest and for your workplace unless you start just playing with it and just use the things. And I've seen in a variety of different kinds of workplaces, et cetera, the people who are staying curious and are willing to um, just experiment are the ones who are really coming out quickly and ahead. And so I think those are the core things that I would say. And honestly, the whole notion of prompt engineering, et cetera, that was so 2023. We just don't care about that anymore. Like I just think increasingly, and that's part of what I mean as well. Like, don't people who over-index on the nuts and bolts of using the AI, I think are missing really a lot of the power and the utility that you're going to be able to get from it as it quickly adapts to us. So I'll just stop there.
Those are really important points, Ed, because we talk about it advancing and it's, at an exponential rate, right? It's advancing and accelerating. However, I think you both point out those human traits remain human. So focus on those, whether it's human communication, leadership, curiosity. Don't focus on, do I need to be a coder? No. Do I need to be a prompt engineer? No, but focus on these human traits. Very, very important. Troy, same question from you. From your perspective, what education and skills do you think students will need to be successful in their careers with advances in AI? Being at Austin Community College, I'm sure just as I do at UT, you get this question a lot from students.
Yeah, I do. And they feel comforted knowing that they're in a kind of a human-centered, at least my students' pathway, that they're working to be technicians or welders or construction workers. They get some comfort and they kind of relieve some of the pressure and they can play and experiment with AI. They can ask it questions. I was just playing around with ChatGPT and discussing with a welding professor, putting in welding, asking it to generate welding procedure specifications, WPSs. And I think that's something that students and teachers will do is say, hey, go generate a welding procedure specification for something weird and go produce the weld. And it's an experiment and it keeps my students engaging with AI, get some testing it. They have to make a well. They have to then do tensile pools and do destructive testing on it so they can determine whether the procedure is sound or not. So I think it's just kind of staying comfortable with experimenting and learning it, and that's how you gain. That's how my students gain experience.
Absolutely. Experiential learning is so important. With the Smart Hand Tools project, and again, thank you all for being on our advisory board, using our participatory design approach where we've done, research and qualitative work and observations and interviews and surveys in the field with workers. We have had two prototypes, a welding simulator that uses augmented reality and an AI-enabled smart rotary tool are two that we have developed. Charles, you already spoke some to the Smart Hand Tools project with the City of Austin. But Ed and Troy, I wonder if you could each address what you see as the importance of the Smart Hand Tools project and what would be the promise of the Smart Hand tool.
I'll start because I think Troy's going to have the real say here because he's in it. But for me, I think there's two things that are really exciting about it. One is exactly this notion of cost reducing training and really sort of like democratizing the notion that I can start to learn to use these tools in a way that is massively cost reduced, that is a little bit more comfortable, and that then allows these what are, I mean, welding is like for some people, it seems like this crazy esoteric thing. And then that's core to our civilization in a lot of ways. And so the notion that you can just start to actually learn this stuff, use it, and not have to, get completely geared up and use the scary big arc systems and gases and all that kind of stuff. And then it kind of eases you into it. So that's one thing. But the second thing that I think has been really exciting about the Smart Hand Tools project, for me, there's a technical aspect of trying to take these things that are very tactile, sensory-based things of you're in the field using these systems, and then figuring out what is critical for bridging, for allowing us to then learn to use these things sort of within the just smartphones and little devices that are like 3D printed, et cetera. From a technical perspective, that's just super interesting and very innovative and is really cool. It also enables something, and I love this, that it enables us to start playing with things like, for instance, well, what would it be if you were going to try to do something to support deaf welders? A really key thing in welding is the sound of the weld being made, the sound of the popping and the hissing and the arc and all that kind of stuff. But deaf welders are missing that. They've got vision very clearly, but then can you start to supply that audio in something tactile? Can you start to supplement sensory elements that then provide these other kinds of things that are really important? And for me, that's a really exciting aspect of the project.
And it gets back to the importance of accessibility for all. And in fact, we did start with Smart Hand Tools with some interviews with deaf welders. So it is incredibly important to always be cognizant of accessibility for all. Troy, what do you think are the promises of Smart Hand Tools?
I think, and to kind of touch on what you said, the accessibility of the training, I think, is going to be as a benefit and is crucial. I've trained deaf welding students. We've had programs over the years with Texas School for the Deaf, dual credit welding programs with them. And you're right about the listening and the sound of the weld. It puts them at a disadvantage if they can't hear the weld. And so to have a tool that can help determine why you get a specific sound. You get a specific sound if you're doing something correctly or incorrectly. And if that tool can, instead of making the noise, but flash a light, a certain color, it'll make the time to training much faster for those students and attainable, when I've trained welding students, if they're going, since they can't hear the sound, if they're doing something wrong, we'll flash a finger in front of their eyes while they're welding, or we'll tap their left shoulder or right shoulder to indicate that they're going too fast or too slow, and they can't hear the result of their incorrect procedure, but we can tell them. So to have something they can work on, again, off-site or at home or not in a lab setting, I think will benefit them tremendously. When someone's making a weld, they're making hundreds of decisions at one. I don't know if it's hundreds, many decisions at one time. And so to have a tool that can get somebody comfortable or used to doing that, a tool that's saying, watch angle, watch travel speed, watch arc length, watch all these things. I think it's just will produce probably a better welder faster. And so, yeah, it's something that I think trainers are generally excited about, skeptical, but excited about it too.
Some healthy skepticism, perhaps. And Troy,
Yeah.
thank you for highlighting the importance of smart hand tools in the learning environment. I have one quick question for each of you, and then I think we have a couple of audience questions. So, Charles, we will start with you. What is one thought that you would like the audience to take away from this panel? What's the one takeaway that you want them to have from this panel?
Yeah, I would say kind of back to the previous question is when I spoke to the folks that have been lucky enough to work with UT on this project, I was assuming that they'd be very excited about the tools and the technology, but they were really interested more in the process. So I think it was the real promise is cultural. When you have workers that can early on co-design these tools, co-create processes and new workflows, new ways of service delivery and operations optimization, and really shaping those things around values and not the other way around. And they see that we're using these tools to kind of elevate human excellence and human capability rather than diminishing it or replacing it. So that would be my first point. And the second point is look for those places especially if you're in a large, complex organization, look for those places where you might not immediately assume there's a good fit for AI. Again, I was very pleased with this project, and we started, 2-3 years ago with skilled trade workers. And I don't know of any other city that kind of really started or was one of the first places when they started talking about AI. It wasn't the knowledge workers and the office workers. It was people that were, out in the field and maybe unsafe, precarious situations, and how AI might help out there.
So keep your mind open to how AI can really help, and don't be closed-minded when you think of AI, but be open-minded with AI and be collaborative with AI, not top-down, but co-create and co-design. Thank you, Charles. Ed, what's a thought that you would like the audience to take away from this panel?
Well, I think I'm just going to echo Charles a little bit here in that the one thing is that when we talk about AI, the sort of characterization that everybody has is that it's all about text and speech and chat bots and that kind of thing. But one of the things I love about this is that it shows the way in which AI and these technologies can intersect with our lived world and the world of trades and the world of just built made things. And it's real, and it can be really substantial, that assistance and that improvement. Of course, we have to be careful about it, and we have to center the people. We have to, not let the technology run away from us and the way we think about it. But I really do think that notion of moving AI into our hands, into our built environment, into the things that we do and manipulate around us is something that we're just at the tip of, and that it's going to become more and more important. And I do really love this project at taking that very upfront. Like, we're just going to really think about hand tools and the way in which technology can intersect with that, which I think is just fabulous.
Well, thank you. And so taking AI into the wild, so to speak, but don't be wild with it. Be responsible, think about human agency and human in the loop, but go to where the people are, right? And Troy, what's one thought that you would like the audience to take away from this panel?
It's that skilled trade workers are also knowledge workers, and when we're testing these tools and trying to apply them, we need to make sure we're seeking their input and taking it into account, and trying to understand what they're saying and describing, and I think that's how we'll develop better and smarter tools.
Very well put. Each of you talked about really not stereotyping and not making assumptions about AI and people. And certainly, Troy, you're right. We have seen through this project, working in the field, the interviews, that skilled trade workers are knowledge workers, and it can be very difficult for them to pass on that knowledge, both in training and in the field. So thank you for highlighting that. I think we have time for a question now. And the first one we have, how much of transparency when we're talking about future of work, whether it's with knowledge workers, skilled trades, and both and all, relies on ethical human behavior?
All of it.
All of it.
I mean, like when we talk about the notion of ethics, like at base, that is us. And that's where it derives from. And any alignment or ethics or the kinds of stuff that any of our AI systems, or frankly, any of our organizational systems, like that's a lot of what this transparency is about, does your organization allow you to understand what's really happening in it? And that comes down to us. So, I mean, I'm not sure what to make of the question, because to me, it really fundamentally is the basic platform that we're building on is human ethics. I don't know.
So yes, human ethics is the platform, the foundation. Charles?
I don't know how to add. I would also say all of it. I suppose you could put some sort of systems in place that would force ethics in a way, but I don't think we want to go there. So let's take the human approach first.
But perhaps does this interact, you, since you're at the city and I know have been steeped in the policy world, does this interact with the types of policies perhaps that the city is developing when we talk about the ethics?
It does, but it's not drastically different than things that than policies that we've had in the past around data, open data, public information, those types of things. The core message is still the same when it comes to all these data, these assets, information. I don't own those things. The citizens, the residents of Austin, the residents of the world own those things. We're just here to make sure that they're created and monitored responsibly and ethically. and the policies around AI, like I mentioned, they're the same that they've always been when we've talked about
Right.
handling the city's assets and the residents' assets as responsibly and ethically as possible. So it's a good
So
opportunity. It's a good opportunity to reiterate it. But it's the same thing I was telling people about open data, in 2013 and 2014 is, essentially the same message is it's up to the individual.
yes, so you're as an employee at the city of Austin, you're a steward, right?
Right. That's the word.
For the public and with all public data and information. So it starts with those who are working at the city, no matter their field, to keep that in mind, right?
Right.
Okay, Troy, ethics.
I confer with my colleagues on that question. Thank you.
Okay, all right. And we have one other question. It's an environmental question, and so they're wondering about this. We've been talking about future of work and AI. To continue to have AI, the effects on, for instance, energy and water that we see with the large data centers. Thoughts on that, anyone, before we close out in the next minute?
Yeah, I think we need a whole other session for this one. I mean, this is incredibly deep, and we didn't
Yes.
even really touch on this, but they're very valid questions.
And I
Yeah.
concur with you. We are coming to a conclusion, and I do think that it's a very important topic. And perhaps we'll have a panel in the future where we can really delve into that. And I know it's one that, ACC and the city and everyone, we're all contemplating what does this mean for our environment, particularly when we look at the electric grid and water. Thank you so much for being here with us today, to our audience. And thank you to our esteemed panelists for being with us here today.
Thank you,
Thank you
Sherry.
so much.
Having it, Sherry.
Bye-bye.
All right. I guess we'll get started. If all of our panelists can kind of, start your video at least, and we'll talk about responsible AI and interactive robots. Quickly, I think that what I'll do is introduce what we mean by robots, because there are lots of different types of robots that you may have encountered at some point. Many of you may be familiar with automotive assembly robots, which just kind of perform repetitive motions. And those aren't entirely outside the scope of what we're talking about today, but I think that most of us in this room work with the types of robots that you may one day, go up to, talk to, ask to perform tasks for you that may be deployed in your homes. Everyone on this panel will have slightly different experience with those things. But these are still largely hypothetical. You'll see some of them in out in public places like airports or demonstrations, or maybe a service robot that you see at like a hospital or a restaurant. But for the most part, we're talking about technologies that are still fairly forward-looking. I'm going to let the panelists go ahead and kind of introduce themselves.
Thanks, Justin. Like Justin said, my name's Nathan Choi. I am a new postdoc here at UT. I study human-robot interaction, and previously I just finished my PhD under Marinol Vasquez at Yale.
Hi, everyone. I'm Andrea Bobu. I'm an assistant professor at MIT in Aeroastro and CSAIL. And in our lab, we work on robots that learn how to do tasks for, with, and around people. So something that's really important to us is this intersection of algorithmic human-robot interaction and human-centric robot learning.
Hi, my name is Ruth Mirsky. I'm an assistant professor in the computer science department at Tufts University. My research is also HRI, multi-agent systems, a lot around how to make robots and agents in general are better collaborators to people.
I'm Justin Hart. I'm assistant professor of practice here at UT Austin. I'm part of the Department of Computer Science and the Good Systems Living and Working with Robots group. I work on artificial intelligence and human-robot interaction, in particular things like service robots and performing social human-robot interaction. We have a couple seed questions. If you want to pose questions during the panel, go ahead and put them into the Q&A. I'm happy to kind of roll with the discussion as it goes. But just a seed discussion, I think that a lot of people are now familiar with things like large language models, systems like ChatGPT, the ethical responsibilities that have come up as it relates to those things. And so maybe a good starting place is, how is robotics different from that? What are the ethical responsibilities for people who are working in robotics that differentiate themselves from people working on things like large language models? Does anyone want to go first on that one?
I can go first. Yeah, I mean, what's different is that robots are physical embodied systems that act in the world that we are also living in. And so notions of safety are very different, because now you have the idea of physical safety. The kinds of sensors that these robots have access to are also different, because these robots now have visual sensors for kind of the images that are happening in the world. They have microphones, they can have LiDAR, etc. So there's a lot more information that they can get about us than just text, which is the main interface in ChatGPT or other large language models. There's the fact that you have potentially, you may have probably in the future, proximity to vulnerable populations. Maybe you're going to have these robots deployed in hospitals, or maybe deployed around children. And so you have to think about that as well. But you also have the issue of privacy, because robots get all of this extra information, visual information, microphone, and maybe the robot is in your home. You have to think about the trade-off of how much information do I let the robot collect about me versus how much privacy am I okay giving up in order for this robot to learn more about me and personalize to me. And so, yeah, generally, it's just you give access to a lot more information about yourself to robots, and these robots embody the physical space that we embody as well. And so that changes notions of safety, notion of co-adaptation, etc.
So I can go next. When we talk about agents now, AI agents, sometimes we use the word agents to describe a function that gets an input and has some output, and that's it. And I think that when we think about agents in the multi-agent systems, for example, and in robotics as well, often an agent has sensing capability. Also, a robot has sensing capabilities, have some decision making, and some actuation at the end. And like Andrea mentioned, a lot of the sensing and a lot of the actuation is significantly more complex in physical systems. So they are more agents than the AI agents that we have online. So we talk about RAG, for example, for retrieval, but a physical agent needs to fetch things from a different room. That has so many additional implications. Every analogy we can think of in artificial agents, I think we have at least as hard of a problem when we work with robots.
Nathan, do you have any thoughts on this?
Yeah, I think those are both great points, thinking about embodied agents as something different and beyond. And I would just like to, I guess, take that thought one step further and highlight that idea of interaction, because when we interact with a situated computer interface, whether it's on a phone or whether it's on your mobile device or at a desktop, we get to choose when that interaction starts and when it ends. But when we have embodied agents potentially roaming in our environments, interacting with us, having those extra sensors and the ability to manipulate the world, that choice of when we interact is no longer really ours. Like the agent itself has some choice, and that in itself, I think, poses interesting ethical questions.
So, y'all mentioned having, the ability to wander around places like your home. You all mentioned, one, interacting with people, but I'm going to expand on wandering around private spaces. So, you have a robot, it has many sensors on it, cameras and microphones, and it is wandering around your home. Does this introduce new privacy concerns, right? Or are these basically privacy concerns we've already dealt with? You already have smart speakers, they already have a microphone. Conceptually, they could already be recording. People report seeing ads for things that they talked about rather than things that they typed into their search bar or had in their email. I've certainly had advertisements for things that are very specific to me, like you just bought a milling machine, would you like another milling machine? You know, um, so, is this different from what we're facing now, or is it more of the same?
So I think if I understand correctly, you're talking about proactiveness.
Well,
And
maybe both proactiveness and the variety of sensors, the amount of data that can be collected, right? Like right now, I'm also not aiming my smartphone around my home, looking at things like, I don't know, the combination to open my front door, or listening in on private conversations, hopefully, about, like my hopes and fears, or, my family's medical diagnoses, or things like that.
I mean, in some ways, access to audio data, microphone, and so on. Yes, we have these smart speakers in our homes that have existed for a while, so that's maybe not new. But the visual data, that is definitely new territory. Having a robot that has a camera, and it needs a camera. Robots need a camera to be able to move and like map the world and make sense of the world. If you tell it, "Hey, give me like a Diet Coke or whatever," it needs to be able to recognize, like, well, not be able to see the world navigate and then recognize this Diet Coke. Um, so yeah, if you now have visual data streams, that is a totally different channel of privacy and of kinds of information that robots can collect about you. And so that's one point. The other point is that, okay, fair enough, it's still common to microphone data, but what about people that don't necessarily live at your place? They're just your friends, or people just visiting your place, and now you have this issue of they never signed up to give their data to your robot. How are you going to deal with that kind of privacy of people that don't even live in the same household as this robot? So yeah, it's definitely a totally new landscape. And I mean, there's some overlaps, but the fact that you have this visual stream of information poses totally new challenges.
Along those same lines, thinking about the interfaces we interact with virtual agents through, we can tell when agent capabilities change because we can see a change in a version number, maybe a new version of a language model, or you can see a new UI. However, when we have embodied robots that roam around our homes or collect data through sensors or communicate with us, it's often really hard to tell what's going on in the processing side of that embodied agent. So setting expectations correctly, allowing people to understand what data is being collected, how it's being used, and how that could impact them in the future, I think is also really important. Trying to make the whole stack beyond the hardware into the software more transparent.
I think that ties in also what Nathan just said to the concept. Early, it was called back channeling, implicit communication. There's so much for just here in this panel. Who's gonna talk before whom, and we need to navigate that. And this is more difficult than if we were in person, just because we are using very implicit cues to signal that we are ready to speak now, or that we want to pass the microphone to someone else. And these are things that I think we would also need to consider for a robot around us, expectations that we might have about the robot's behavior and things that we cannot detect from the robot. Like Justin and I are collaborator on an eye gaze paper where you use the direction that the robot is looking at to understand where they're going, because we do that as people. We use people's eyes to understand where they're going.
You guys can feel free to follow up on each other, but I think what I'm going to do is we actually do have a few questions from folks in the audience. So we have two right now. One is not necessarily ethically related, but it's still pretty fun. So I think that we're going to go ahead and handle it. Vasant Thadness asks, do we know who's working on a robot that does dishes? When I asked a few folks, cobot that does dishes and cleaning was on the top of their list. So does anyone know people who are working on that specifically? Or maybe other domestic chores, and I can give a little insight, but I'm the moderator, so I'm going to try to leave myself out of this.
I mean, there's a few companies. I'm sure Physical Intelligence is working on this. There used to be this company, Dishcraft Robotics, that was specifically looking at the dishwasher, dish loading robot. I'm not sure if it still exists. I'm sure, I think there's a lot of companies more recently that have cropped up that look at humanoid robots to do your chores. Maybe some people in the audience saw the Neo robot recently. That will actually start being sold, and that's an entire can of worms that people in the robotics community have been discussing. So yeah, there's a lot of people working on it, but it's a really difficult problem because of the variety of different homes and home configurations and the like even preferences sometimes for how different people want to have their dishes loaded or unloaded, or how to use the dishwasher. Like some people use the dishwasher just as a drying rack, not necessarily as a dishwasher. So there's a lot of variety in like home environments, people's possessions that you would like, objects that you would put in the dishwasher, and people's preferences, like how you should load or unload the dishwasher, and etc. So there's kind of the first stage of why this is difficult, which is just physically going and or having a robot physically going and doing these tasks is difficult. There's a lot of manipulation. Imagine having to press the button on the dishwasher. It's a pretty small button. You need to be pretty precise. And there's the second hard aspect of this, which is the more human aspect of how do I interact with this person's possessions? How do I learn this person's preferences for how to have their their dishes washed, etc. So there's both of these things are really difficult. I think a lot of companies are currently focusing on the first element more so than the second.
So I think it's an instance of Moravec's paradox, where tasks that are difficult for humans are easy for machines and vice versa. Gripping, like you've mentioned, is something that we have amazing sensors in our hands to feel things, and if they're slippery or they're soft, and we can do textures very well, and making a robot understand that and being able to wash dishes. I'm more familiar of people trying to solve this problem in assistive robotics for feeding, for example, or helping people get dressed. And these are things that just picking up a grape is very different than picking up a spoonful of soup, for example, or cutting meat. So these are very challenging tasks from that sense. I will say something, it might be a bit controversial. I also think that everyone wants a robot that does dishes, but it's not potentially as exciting problem research-wise compared to other stuff that you can work on. And I think that if you're doing fundamental science, sometimes this is just not the top priority to tailor that thing that would be able to work with your dishes.
Nathan, do you have any follow-up?
Yeah, I guess thinking about the way that companies, I think Andrea mentioned at the beginning of her comment that there are several companies working on this type of task. Companies tend to use a teleoperation or some sort of engineering approach to bridge the gap between what needs to be done, the task at the end of the day, and kind of the current state of research. And thinking about that gap, opens up ethical questions in terms of having someone teleoperating a robot in your home, but also a question going to your point about Ruth, about basic science, like what role does teleoperation play, and will that get us to the point of where we can solve these problems? I wonder.
Well, there's another question from the audience, and I think that that is actually fairly relevant to some stuff that we were kind of talking about in our pre-panel discussion with Nathan. This one's from an anonymous attendee. Uh, Sounds like a member of the faculty, um, which is how would using or collaborating with robots affect human-to-human interactions? For example, I'm already feeling the erosion of my relationality, i.e., my colleague to choose to collaborate with ChatGPT over myself in writing a book chapter or, a grant proposal, things like that. So, like, how is it, the heart of the question is, what are the potential impacts of having robot collaborators, in our lives, as far as it relates to our human collaborations and our human relationships, Another good example that I can draw on is 2 years ago at HRI, there's a paper about making kids be polite to smart speakers because they found that that imperative command being made to the smart speaker was causing them to be rude in other interactions, right? Like, get me the thing, as opposed to, would you please get me the thing? And then, having the smart speaker enforce that social policy, So we don't have to go quite down that route, but you get the family of what we're talking about here.
Yeah, I can speak to this a little bit. I've actually been thinking about this a lot lately in terms of human agent interaction, embodied or not. We typically model the learning process as there being a human designer, and then that human designer comes up with some reward or some objective for that agent. And then we come up with some process to optimize for that objective to try to get the agent to do what the human wants. Um, but I've been thinking about changing this paradigm, something I've called bidirectional value alignment, and incorporating the human designer into that process directly, having the agent think about and try to estimate the internal state of that person, and then try to better align its policies to that person via the internal state. There are lots of problems and potential ethical concerns with this, but I think this could be a way of actually incorporating this human agent and potentially human agent, and incorporating all of these actors into the actual models that we have so that we can better directly address them, because it is happening now. It's just implicit, and we aren't really dealing with those types of interactions and how they can shape, really how agents can shape people in the long term.
I think
There's
this is,
the,
oh, go
sorry.
on. No, go ahead.
So one thing I've been curious about as well is not human-human, but human-animal-machine teaming. And how can we incorporate robots to work both with people and animals? For example, if you think about a vacuum cleaner, robotic vacuum cleaner in your house, would you think that people with dogs would have more or less vacuum cleaners? On one hand, the hair around the house potentially means that they would appreciate a vacuum cleaner. On the other hand, potentially some of the dogs won't appreciate the intrusion. And designing robots properly to houses that have pets in them can have a huge implication. We all know the cats that roam around on the vacuum cleaners. So I'm not familiar with thorough research being done on that, but I think it's very exciting to see how when we want robots to be part of our lives, we also need to consider that we have pets and the like.
Andrea, any thoughts?
Yeah, I don't know that I have a whole lot of thoughts on how it's going to affect human-human interaction. I have thoughts on how, like, what is the role of a robot in our lives and the kinds of tasks that robots will hopefully start doing. Ideally, we would like robots to do tasks that are dangerous or repetitive for us. And ideally, we would also like robots to kind of somehow augment or amplify our life somehow. Maybe we have a robot sous chef for example, in our home. I find it very annoying to chop vegetables. It wouldn't be nice and maybe even more fun if I had a robot I could um, tell to chop my vegetables. Maybe I can have a conversation with it while I'm cooking or doing other stuff. I think if if I think about the application of elderly care, which it's a huge problem, and I can imagine that if you were to have a robot that's quite human-like, that remembers what time to wake you up and what time to administer medication, and maybe helps you move from one place to another in your home. I could imagine that it would be, well, assuming that there's no one else in your life that can help you. I think that that would significantly improve my quality of life, just to have another entity that I can interact with, and that kind of takes care of my livelihood a little bit, at least. It can probably feel quite empowering. So this answer isn't exactly about the human interaction aspect, but more so about thinking about how robots can supplement our interactions in some cases. Now, if I do have the robot sous chef, does that mean that I'm going to cook with fewer people? I don't know, because if I want to hang out with a friend, it might actually be quite interesting to have multi-human, multi-robot, or multi-human single robot interactions where we like that you have a like me and the friend and the robot all interacting, putting together the dinner. Maybe the robot can help us set up the table, and the two of us can actually do the cooking, or maybe the robot helps do the cleaning. So I think it's interesting to think about how having robots can even amplify or augment human interaction or human interaction, and not just detract.
We have a few audience questions, but I think that I want to jump to something that we discussed a little bit before the panel, because I think that it leads into some of these other questions. And I think that you guys have been leading into some of the stuff that the audience is asking, which is like, guardrails have become sort of a standard method for constraining large language model behavior. And we all kind of understand what a guardrail is, but maybe for the audience, a guardrail is like if you asked ChatGPT to draw you maybe a political cartoon, right? It would just refuse. It just has an instruction and says, don't do that. It classifies it very quickly, says, don't do this. If you asked it to do something illegal, it would tell you, I can't assist you in doing something illegal, right? And so, that's, even in the currently deployed systems, that's kind of a clunky approach, right? It certainly limits what large language models can discuss, even if it's stuff that's reasonable to ask it, right? Like if you wanted it to analyze a bunch of political discourse for a research paper, you probably can't get a straight answer. Or if you wanted to comment on art, there's a lot of art there, it just probably can't even adequately describe, right? And so, we're looking at deploying these systems, in people's homes and in public spaces, interacting with people, and probably such a clunky solution isn't going to be so desirable, right? So the question is like, is there a version of a guardrail for a robot, or is that the wrong solution entirely? Do we have some thoughts?
So I'll start with this one. It's very related to my research in which I explore intelligent disobedience. When should robots and AI disobey an instruction? And my motivating example is a guide robot for people with visual impairment that usually when a car is coming, and this happens with real guide dogs as well, that when a car is coming, if the person wants to cross the street because they don't hear the car, the dog would refuse crossing. It's like a physical guardrail. I'm not going to let you do that right now. And the reason the dog knows to intelligently disobey is because something related to what Andreas mentioned. We have such a richness of sensors on our robots. The capabilities, both sensing capabilities and actuation capabilities of our robots, often surpass those of their human teammates right now. And I think that what we want to achieve basically is that when the robot has the better capability, potentially it should not be disallowed to do something, or we should let the robot perform what they can do better than us or make the decision better than us. Obviously, I think that when we think about the decision-making component, people are still most of the time have better contextual understanding, higher cognitive ability. So this is where there should still be some restriction on what we allow or don't allow our robots to do. But definitely, I think that physical guardrails are also something that we should look into and understand. When and how do we want to allow robots to do something that is potentially unsafe? Like if we don't want a robot to drive at too quick of a speed, but potentially if there's an emergency that they need to go for, like an ambulance, we need to enable a signal and allow the ambulance to cross when the light is red. So we want to have something similar for robots as well.
Yeah, I mean, there's things that context-aware constraints maybe that we can have. Like there's a maximum speed that you should not go over near humans. Or maybe there's restricted zones. If I tell you never ever enter my office, the robot should know to never do that. But I guess there's always, so you can actually start talking about guardrails even in computer use agents. So back to LLM land. There is a discussion about, computer use are basically these systems that are primarily LLM powered, and they can, for instance, operate your computer. You tell this agent, hey, go book a flight for blah. And it goes and, has access to a mouse, and it can click places, it can open a tab, it can log into websites, etc. And so there's a lot of research people are doing into guardrails for these kinds of situations of, one, determining when the prompt itself, like the request itself, is unsafe. That's a very obvious type of guardrail, but sometimes requests that are seemingly not unsafe end up placing the agent in an unsafe situation. Like maybe I ask you, hey, can you teach me how to, I don't know, no, I'm not going to ask you, teach me how to do retail fraud, but maybe I say, hey, can you teach me how I might go about returning, like buying this item from this store and then returning it at a different location, or I don't know, something else more subtle that maybe these kind of pre-execution guardrails don't catch, but then you actually execute the behavior and realize, oh, this was actually a malicious action to undertake. And so sometimes things that are, it's not just the prompts that are unsafe or the instructions that are unsafe. You might end up in unsafe behaviors and realize kind of after the fact that you ended up in that unsafe situation, and you have to think about, okay, how do I remediate this harm? So these kinds of questions are something that we're already starting to ask, even in the LLM agentic kind of computer use agents world. And the biggest issue, or one big issue, is this trade-off between, if I was trying to think about every prompt and how it could possibly conceivably become nefarious or, put me in an unsafe situation, then I might end up being overly conservative. Like I might be thinking, well, is there any way in which asking the robot to bring my guest a can of Coke, could that be nefarious? And you could hypothesize, well, if the can of Coke was poisoned, or if the can of Coke happens to have almond, and if this person is allergic to nuts, then maybe it could be a bad thing. It could be potentially unsafe. But there's this trade-off of being overly conservative and as a result doing nothing, or just kind of being paralyzed, versus trying to relax some constraints to be able to actually be useful and actually do tasks for people. And so I think this is something that we have to think about when we think about guardrails. There's trade-off between how much we prioritize safety and guardrails versus how useful this machine is actually going to be. And it's not exactly clear to me how, like, I mean, it's definitely a case by case basis. Yeah.
So we're going back to Isaac Asimov's laws of robotics. We want the robot to make no harm to people, to comply with everything we tell it as long as it doesn't harm people, and we want it to make its own safety a priority as well after the two laws, right? It's easy when we describe it this way. It sounds compelling. How do we make that work in physical robots? It's becoming a much more complex problem.
I agree. And as robot capabilities continue to increase, I think we're going to see more and more of this problem that I think about as a problem of inseparability. If you want to give a robot a capability, like you just mentioned, not harming humans, well, people are designing humans to work on the battlefield. And if you want those battlefield robots to be effective, they're going to have to make some choice between harming one person or another, protecting someone or not. And if we give a robot a capability to do one thing that could potentially be used for good, I think it ultimately could probably be applied for bad as well. So we need to figure out, like you're talking about, Andrea, the context awareness of those rules, and how to adhere to them.
I'm gonna go ahead and there's now quite a few audience questions. So I think that we're going to jump into a few of them. So there are a couple basically on human robot interaction and like the human element of it. And so I'm going to kind of group these together. So one follow-up question was that we sort of talked about impacts on human robot interaction in this like professional environment, but like the impact on like day-to-day, like how we interact with our friends and our family, right? Like in our homes, and that there's no monetary incentive to interact with them. And then Greg Jewett said that he literally watches a television show where they address how to keep processes when working with other humans sort of as human as possible and not overly optimized to be like robotic. So these are a little scattered, but I guess the core of the question is, what are our responsibilities in terms of the human robot interaction and how this impacts how we interact with other people after interacting with these devices? Like, is this going to, shape our social behavior in some way that is, positive or negative, right? And what can we do about that?
Yeah. Sorry. Okay, I can start at this question. I think that maybe this doesn't need to be said, but I think inherently we want to build systems that are pro-human. And while robots could be good or evil and used either way, if we aim to build systems that inherently prioritize the human, assist the human, and make those interactions human-centric first, that is the right starting point and direction. I think that along with making those interactions human-centric, thinking about not just short-term interactions, but long-term interactions is critical because we can optimize for immediate task completion or reward of some form while ignoring kind of that long-term interaction where a person learns how capable a robot is, how the interaction might unfold in the future, and therefore can plan appropriately and hopefully over the long term, that interaction, and I hesitate to call it a relationship, but that ongoing interaction with the robot can improve and increase in positivity versus going the other direction.
Other thoughts on this?
I have two anecdotes about research I'm familiar with. One is personal. When I started working with a spot robot around campus, one of the first things that people have tried to do is to kick it, because they've seen the Boston Dynamics commercials of kicking robots. So they thought that is a socially acceptable behavior. And I think that one of the things we as roboticists can do when we do interact with general public, with users of our robots, is ensuring that we are developing a good social behavior, both from the robots end as much as we can, and from the people who are going to use that. The second, maybe it goes back also for the question about the human-human interaction. There is a fantastic social companion robot called Paro, which is a seal-like robot. It's super cute. And when they've started deploying that in elderly care houses, people liked it. It got fantastic results. But at the end of the experiment, they've asked the participants, would you like to keep the robot? And most of them said no. And the reason was because when they had a robot, their family members felt like they can get a little slack not calling every day because they have Paro as a social companion. And as good as the interaction was, it was not replacing human interaction. It wasn't replacing their family calling them. So I think we talk a lot about social companion and about having robots that would have some emotional connection to us as well. And will they be able to replace humans or our need in social behavior? For now, I think we are very far from that, at least on emotionally, socially.
The Ruth's story on the robot that is getting kicked reminded me of this anecdote with Waymo. So I go to San Francisco quite a bit, and so there's a lot of Waymo cars driving around the city. And I was once in a friend's car. We were driving. I wasn't the one driving, but we were supposed to take a left, an unprotected left. And in front of us, the first car waiting at a red light was a Waymo. And so then the light turns green, and she's like, "Oh, I'm just going to turn left because the Waymo isn't going to crash into me." So it was interesting to think about humans now knowing about how robots work. They're starting to game robots themselves. I don't know how you would prevent something like this. Because yeah, the friend was right. Waymo has all of these safety assurances built into it that would have probably prevented it from, you know, uh, going and crashing into someone who's taking a unprotected left, kind of out of turn. But yeah, just wanted to bring up the point of humans are now also starting to think and figure out how to game robots and like how to take advantage of knowing that some of the agents that they're interacting with are robots and they have all of these guardrails programmed into them.
Nathan, any thoughts? Okay.
Yep.
We still have some more audience questions. We have some stuff that we talked about when preparing for this panel. So I'm going to pose to you guys, is there anything that we discussed, during our prep for this panel that we wanted to talk about? Because we only have about 8 minutes left. Was there something that that you were really hoping that we would discuss? And if not, then I'm going to jump over to some of the audience questions that kind of link in. Okay. One, I'm not sure we're in a great position to answer, but I'm going to throw it out anyway because it links in. And then just another comment, one one being there was the cat that was run over in San Francisco, and who sort of like bears the legal responsibility, in that situation. Is it like basically, I think the question is like, is it a software flaw? And, sort of like, maybe the car is responsible. Is Waymo legally culpable? I certainly don't feel like I know enough about law to answer that, but if you guys feel like you have that, and then just another observation that you know that reactions to like Teslas and things like that can also be very similar. That it's like, people cut you off in these cars because they know that they have a safety feature to prevent you from colliding. Yeah, at the same time, like maybe there's a human driver behind there, maybe they don't even have that feature turned on, right? Like you on most of these cars, you can turn off like lane assist stop assist, things like that. So you could be jumping out in front of a human driver, a very fast car who just is not watching you, right? So do we have any thoughts on this kind of combination of topics, realizing that this is starting to get a little legally into the weeds in a way that is probably beyond the nuance of what I know about fluently.
So yeah, I'm not an expert at all in robot ethics, but one of the faculty members here at Tufts is Matthias Scheutz, who works a lot in this domain. And in our conversation, one of the things that usually comes up is to be accountable for something is meaning that you have the ability to choose what you're gonna do. And if you don't have any decision point, then you can't be accountable. So if the robot is not intelligent in the sense that it could have made a decision to collide into the person or not, we can't really put it accountable for that. So it is a challenging question. I do think that we will reach a point where robots can be accountable, at least to some extent. But then there's another question of, is there any punishment or a way to ensure that they are staying within whatever they need to do?
I really like this framing of accountability through choice. And I think that, at least I view AI systems as functional systems. I think someone may have mentioned this earlier, but effectively the idea that a machine learning system or an AI system takes in some input, has some set weights from a trained model based on data, or has some rules that a programmer has put into the system, and then it outputs some output based on those things. And it's the people who are designing the models or generating those weights, and then knowing the capability of that system, choosing to deploy it or not in whatever situations it may be capable of handling. Those are the people making the choice, not the system. So that's how I view it.
Yeah, I'm also not an expert in ethical AI, but the one point that I wanted to make about KitKat is, while it is tragic what happened, at the same time, the rate of accident for self-driving cars is so much lower than the rate of accident for human drivers that, I mean, it's obviously we're going to see news like this happen. It's not bulletproof technology, but we have to also recognize how much better or how much safer it seems like these systems are in under certain circumstances. So I think it's easy to focus on the one or two newspaper articles that we see that are high profile about horrible things that happen. But the reality is that when you look at it statistically, it really does seem like self-driving cars are actually a lot safer than human drivers.
So, yeah.
No, go ahead.
So one point that usually, again, is brought up in this type of discussions is, you're right that autonomous vehicles are less involved in accidents, but the accidents they are involved in could have been prevented by a human driver, probably. And this is the one thing that usually people get upset about, because this could have been prevented. It feels like it's something that shouldn't have happened when a person does something. Yeah.
I think well, okay, I didn't read into this too much, but I thought the KitKat accident was actually quite a kind of crazy circumstance where the cat got under the car. So I think, and I think the car was already parked, and someone was getting in or getting out or something, and in the meantime the cat got under the car or something like this happened. I feel like I would have probably had a hard time with that as a human too.
So I had a cat on my engine, two kittens once, and it took me like 5 minutes to realize I'm hearing something and I'm not crazy. It's really a sense like meowing, meowing. I stopped at the side that I took them home, and the next day they went to SPCA. But it happens like for people as well, I think, from that perspective. But I was able to understand the sound, that this is like a kitten sound that they should be aware of. So I'm not saying it's exactly the same thing, but we do have more sensing capabilities for across different modalities, I think, as people to still be able to manage a lot of the things where early days of Tesla, when it got hit, like it hit a woman driving a shopping cart because it didn't realize it's a shopping cart. These are the sillier mistakes a person wouldn't have done. But obviously, the better our sensors are getting, we'll see less and less of that, I hope.
Well, so I had one that I was gonna offer to answer live. I'm just gonna quickly say it. I think that we kind of addressed it, which Selwyn can't read this. Pollitt said, as a software developer, I can't imagine how to write bulletproof software, especially for self-driving cars. And does AI solve this somehow? And I think the answer is sort of no. You know, like yeah, my understanding is that KitKat was like hiding under the warm car, and then the car started, and this is just like from a software development perspective, it's kind of an edge case, that the developers weren't thinking of. And, of course, from a human perspective, it killed the cat, which is also pretty awful. But we're kind of at the end of our time. And so, Leia, if I can maybe just give the speakers, like our panelists, just like closing thoughts, and then we can wrap up, I think. Are there any closing thoughts on, our discussion, the theme of the panel, anything you kind of want to throw out there? I know I'm kind of hitting you with this one on the spot. So if you don't have a closing argument, you don't have to make one,
Yep. I'll just briefly reiterate, and it's kind of highlighted by this discussion around self-driving cars and the potential for harm or good. I think we think about the capabilities of robots as sensors improve. Obviously, capabilities will improve, but matching capabilities with what we allow or expect, basically the guardrails on those robots, we'll be in a lot better situation than if we kind of release them too early or wait too long. So something to think about. Matching expectation with reality in both designers' minds and the user's mind is really important.
For me, I'm just very excited to be working in this area right now. I think it's a great time to do this type of research. And I think we need, and I know that all of the panelists do that, collaborate with researchers from different areas to get a better sense of how to make our robots better collaborators.
I think I wanted to kind of inspired by the software developer who can think about everything ahead of time. It's the same thing with our robots. Nobody can think ahead of time of every single situation, but maybe we can have, there's a lot of researchers who are trying to get kind of uncertainty quantification metrics to work, where maybe you can think of every single situation ahead of time, but maybe you can have a prediction of how uncommon is the situation. And if the situation is uncommon, then maybe we can ask for help, defer to a human, proceed carefully, be more conservative. And so that's another way that we can handle those sorts of situations where obviously it's impossible to write everything ahead of time.
Well, let's thank our panelists and our audience. I'm sorry that we didn't get to all the audience questions. We're a little time limited. There's a lot of thought-provoking stuff. I'm really proud of how this panel turned out, though. Like, sometimes robot ethics stuff can be very speculative and like wild thought experiments, right? This really managed to stay very grounded in like real problems, right? Like we didn't talk about, I don't want to pick on any specific problems, but like, for instance, we didn't talk about the possibility of a robot factory turning every human in the world into paper clips. And although this is an interesting, thought experiment, it isn't one that really impacts our day-to-day lives right now, right? And so I think that we managed to keep it pretty grounded, and say pretty, measured, intelligent stuff instead of stuff that's like, way off in outer space. Even if the way off in outer space stuff is sort of exciting from a purely theoretical thought experiment, perspective. So I think that we're done. Do we feel like we had a panel? Does everyone feel good about this? All right, I had fun. All right, thanks, guys.
Thanks, everyone.
All right, let's get started for the last session for the Responsible AI event at UT Austin. We're the last session. Our topic focus on responsible AI and smart city. So good afternoon, everyone. My name is Junfeng Jiao from UT Austin. I'm an associate professor at UT Austin, and thank you so much for joining today's webinar on responsible AI and smart city. At UT, our Good System Grand Challenge brings together researchers from engineering, planning, computer science, social scientists to explore the important question, how we can design, develop, and deploy responsible AI system for our society. Within Good System, the smart city research area is focused on heavily on this effort, how we can design, develop, and deploy responsible AI system to urban to cities. We have used AI technology to develop many examples, such as Austin Digital Twin, which we use digital twin and AI trying to integrate real-time information about mobility, fire risk, climate hazard, noise, safety in one unified platform. We use this digital twin platform to lively monitor the urban mobility, run simulations, predict hazards from noise to other. My previous research has focused on mainly on transportation, from transit to Uber to shared mobility and AV and EVs. So through that research, I learned how powerful AI is and how important we design responsible AI system in mobility and transportation and smart city research. So today, we have a wonderful panel, includes three distinguished researchers to talk about how they use the responsible AI in their own research field. Our first speaker, Dr. Christine Claudy, is an associate professor in the civil architecture engineering department at UT Austin. Our second speaker, Professor Yuan Changxie, is a professor at the Francis College of Engineering at the University of Massachusetts, Lowell. Our third speaker, Dr. Mahadi Naranjad, is an assistant professor in civil engineering at York University in Canada. Without further ado, I will turn the microphone to them. Each of them will make a quick introduction about their research, their focus area. Then we'll go over some questions, and then we will open the floor to the audience. Without further ado, I will hand the microphone to Dr. Christina Claudy to introduce his research and himself.
Thank you very much, Professor Joe. Should I share my screen for the
Yes.
for the slides? Or
Yeah.
Okay, sure. Yeah, we just share very briefly. Okay, so this is just a quick presentation, a quick overview of what we are doing in my research group. So I'm again in transportation. My main interest is actually has been initially traffic control, traffic estimation, but then recently I switched to more AI topics, and in particular, one of the topics that we are very interested in is the prime of traffic safety. So this is an example video that we made in my group using essentially AR systems that forecast user intents essentially, and that integrate with vehicles or with either with vehicles or with other things around to improve safety. So for example, here this is the use case of someone that would be hidden behind a car, but of course the use case go beyond that. We have an example here of someone, for example, using a scooter and the interactions with a vehicle. So the key AI aspects of this system are essentially the ability to forecast paths. So this is a topic that we have started to investigate a couple of years ago. For example, if we have a pedestrian and we use the first-person view data from the pedestrian, and similarly, if we have a driver that we observe, how can we predict their future actions? This is super important if we want to predict the possibility of a crash and to compute the best evasive actions that the user should have. Of course, this goes beyond traffic safety. We are also very interested in using interactions of these with robots, for example, robots plus users. So this is another example video where we have a robot scanning an area and detecting, for example, a victim. So that's used for firefighters, for example, and essentially mapping the position of the victim directly in the video feed of the person in augmented reality. So that's another application. Other topics of interest to us are more core AI topics related, for example, to segmentation. So we have been working on these robots to detect microplastics and to detect microplastics, which are extremely tiny particles of sand, of plastic in the sand. We need to actually segment complex images and extract from these images what are the likely spots that could be plastics. So that's something that we have been working on in terms of developing a robot. And the complexity for us is to more solve an image recognition problem. But another more interesting topic related to AI for transportation is this concept here. We have been working with some of my students on a new type of paramotor drone, and this paramotor drone is actually something very interesting because these platforms are not used often as drones because it's extremely difficult to control in turbulence. So you can see that the effect of turbulence on a parafoil wing, it can cause the wing to collapse or to change its shape in an uncontrollable way. So for this, we are working also very hard on machine learning aspects. So in particular, the problem of forecasting the flow ahead of the wing based on current data and based on measurement of airflows, of current airflows plus accelerations associated with this. So that's also something that we are interested in terms of AI. Yeah. So I will stop here for the presentation.
Thank you so much, Professor Christine Claudier. I just wish the previous panel stay longer because they talk about the cat and autonomous driving vehicles. We are actually this panel doing the related research. Our second speaker will be Professor Yuanchang Xie from University of Massachusetts. Professor Xie, floor is yours.
So hello everyone. Can you hear me okay and also see my screen?
Yes.
All right. Well, thank you for having me. So my name is Yuanchang Xie. I'm a professor of transportation engineering at the University of Massachusetts Lowell. So a lot of my work centered on traffic safety, traffic operations, and asset management. Because of that, our group has done a lot of work with using AI to support the research topics that I just mentioned. So I prepared this brief slide show to demonstrate the work that we have done using AI. So we use AI. We develop supervised learning models to extract pedestrian crosswalks, as you can see on the screen, for safety, mobility, and accessibility analysis. And we apply the model to data from multiple states, including Massachusetts, Florida, Maine, New Hampshire, Washington State. Recently, we're trying to apply this model to Texas data. This is just another example showing the detection results. We have also expanded the work using AI to extract sidewalks. So with sidewalks and pedestrian crossings, and you can have a complete network for non-motorized road users. Just another example for sidewalk. So beyond that, we also did something with pavement marking extraction, because in this way we can combine the pavement marking data with with the crosswalk, and we can better assess the conditions of a crosswalk, not just to detect them, but we also want to know whether they are in good shape or not. This is about payment crack detection. This is critical for asset management and also for safety. We did this quite a while ago. You can see the model is smart enough to differentiate payment cracks from other foreign objects like tree leaves, snow, and paint on the pavement. And recently, we also did some traffic sign detection, not just to detect traffic signs, but also to identify the locations, the lateral distance from the edge of the road without using LiDAR. And with LiDAR, it will be very helpful, but we're trying to figure out a low-cost solution. So just based on images, can we detect those signs, also figure out their distance to the edge of the road? Because signs, utility poles, their lateral distance to the edge of the road can be important for safety analysis. Besides that, we have also done work to detect all different types of road users using regular cameras as well as hybrid thermal cameras. In this way, there would be no privacy issues involved. We have also done work with analyzing video data such as those captured by drones, so we can extract near crash events. As safety is a big part of my research. So this is kind of a quick show of the work that we have done. Besides those slides that I showed you, we have also conducted research to we developed generative AI tools to review menus. There's a lot of menus in our field, such as MUTCD. You have thousands of pages. To find the right section can be difficult. So we develop generative AI tools to facilitate that. Another interesting piece of research is we develop AI tools to analyze police crash reports. So the rationale behind that is if we can dedicate the resources that we dedicate to analyzing aircraft accidents to every single highway accident, then we probably can generate a lot of important insights. So we develop tools to analyze every single crash reports, not just the narratives, but also the diagrams, trying to piece together all the information and to assist with existing highway road safety audits. So you may have seen similar research from other groups, but this is just a quick show of my background, where I'm from. And I would look forward to the discussion later today. All right, thank you.
Thank you, Professor Xie. Very impressive work. And we'll hand over to Professor Mahandi Naranjat for his introduction.
So my name is Mehdi. I'm a professor of civil engineering at York University, and I'm also an Amazon scholar, in which I bring a lot of what I'm going to show you here today. Our lab is called Interactive OR. OR stands for Operations Research, and what we do, our mission is to enhance decision making using interactive machine learning and OR-driven web-based tools. The best way to explain what a tool is to explain it with something that you already know, which is a dashboard, where I'm sure you've all seen dashboards before, which are typically done in Power BI, Tableau, and ArcGIS. And the main purpose of dashboards are that they're great for showing and monitoring historical information, but they don't necessarily do a lot of planning and decision-making scenarios. In terms of analytics, they're very descriptive, whereas tools can be very predictive and prescriptive. Dashboards are very basic in terms of what if interactivity. They're just doing it on filters and views, whereas in tools, you can do advanced what if scenario analysis and so on. The best way to show how they actually look, just confirming you can still see my screen again with a map. Okay, great. So I'll show two quick examples. I was hoping to show a video too. If there's time, we'll do that as well. So this is some of the cases that we have. This one is for emergency management planning. We work with a lot of fire departments to arrange where the stations are going to be. And so the interactivity that I'm referring to on a tool is, for example, you can drag and drop a station. And as you do, you get quick analytics in terms of your response time, which is what a lot of fire departments care about. So this shows you within this coverage area, as you move it around, you get 2, 4, and 6 minute response times. You can see how well you're doing in terms of accessing the population. These are the coverage areas for each of these stations. You can move those around and you can change the boundaries of those stations. You can optimize where the stations should be and a lot of different kinds of analyses that they do. Something I really like to show when I'm presenting this is what the chief and the deputy chief are doing with the tool right now. So this station right now, you see here, doesn't currently exist. This is a town of Fredericton in Canada. And so they've implemented this, and when they go to council to show why they would need a new station in a particular location, they can show this design, they can move it around, and they have another design that they're looking at. And in front of council, they can compare the system level metrics in terms of the response time in each of these zones and the total city level response time at the bottom. We create a lot of these, so we have cases in bike sharing, micromobility planning, and last mile logistics, and a lot of other use cases. This is, for example, another scenario for bike share planning where it allows you to add a station, and once you do, the yellow hexagons appear. These yellow hexagons are where bike share stations are, and there's a machine learning model in the background that predicts what the riderships are going to be if you add a station there. And so it creates what if scenario analysis like this, where you can move, you can drag and drop these stations, and you can see what the predicted riderships are going to be. There's an engine that optimizes this. So typically when you're modeling micromobility systems, you care about accessibility, equity, transit integration. You can see heat maps of where is ideal to add these locations and then pick a number of stations to add. So this does what if scenario analysis. It optimizes in real time where you might want to add these stations, and there's levers of decision making that you can change. So if you care about connectivity a lot and you run this, it puts them kind of within the network. But if you disregard connectivity and care more about location specific features, it puts them within the boundaries further away. And so these are different kinds of scenarios that we've been generating. I'll show you one more example really quick at the end. But I look forward to explaining a lot more of these as we go.
Thank you, everyone, for the wonderful introduction. I have some technical issue with my camera, and I will just start with the questions. Our first question is, how do we design trustworthy and responsible AI system for urban infrastructure so the AI can be embedded in the transportation infrastructure to achieve both technical ability and social trustworthy? Such as application in traffic management, autonomous driving, and energy optimization, and so on and so on. So I actually designed three sub-questions. First sub-question will go to Professor Christina Claudi. So how do we balance the automation and the human oversight? For example, how do we balance human in the loop?
Yeah, thank you very much for the question. Yeah, so that's a very interesting question, and in fact, we are dealing exactly with this exact same question when we work with traffic safety as users. So the goal of our system is to essentially the system that we are trying to build based on augmented reality. The objective of that system is to improve traffic safety by giving all people around the ability to avoid the collision through guidance information, for example, in 3 dimensions or etc., virtual paths, or additional traffic rules, for example, that could be shown to the users. The biggest problem, I think, is really how to trust the AI. So for us, the AI is not used for the decision making. The AI is only used for example, some aspects that are going to be inputs to decision making, like the predictions of the future actions of users. And I think this is an area where AI is particularly useful because we don't have good cognitive models in any case of these things. So the best way is really to do the best guess and the best, I mean, the most effective system that can be used to predict, to do this prediction is AI, because we cannot use dynamical system, classical estimation, or forecast. But we keep some control to the system by not having the decision making done by AI. Currently, I think it's very difficult to trust AI for traffic, for example, safety critical things. And I think the good step forward is to use AI, for example, for the inputs of those systems that have, for example, human in the loop or partial automation or full automation, but make sure that the algorithms that do the automation are relatively simple, predictable, and that are not black box. Even if, of course, the errors of the inputs can affect the outcome of the decision, you still can keep some control or some way to hard code some limits to these actions. That's our philosophy in the topic.
Thank you so much, Professor Claudine. The second question actually goes to Professor Xie. So in your presentation, you showed the safety research at crosswalk, at intersections. So how much you think AI can improve the safety in this intersection domain, and how much you think it's for people to understand the underlying AI algorithm, like explainability of the different AI method in this analysis? That's a second question for Professor Xie.
All right. Thank you for the question. Crosswalk sidewalk research is directly related to safety. The project actually was initiated by our state DOT, MassDOT. They want to see whether the existence of a crosswalk or sidewalk is related to crash frequency or severity. But in this sense, responsible AI is critical because if for crosswalks that are almost worn out or versus those newly painted crosswalks, I mean, the new ones would be easier to be detected. For those are almost worn out, you cannot detect them. So if we miss some of the faded crosswalks, that may give the wrong information for subsequent data analysis or safety risk analysis. So it is important that we have a reliable AI model that can capture both very clearly marked crosswalks and those faded ones. And in addition, it will be great that an AI model can also classify those crosswalks and give you not just the existence, but as well as whether the conditions. So that's just from the crosswalk sidewalk perspective. Another project that a study that we did was to analyze crash reports, including narratives and crash diagrams, and then to figure out. Well, you also know the locations of those crashes. So once we put all the information together, we can identify issues with the infrastructure. Accidents are caused by different factors, right? And from Department of Transportation perspective, and they're directly responsible for infrastructure. So this information is critical for them. In this sense, responsible AI is also critical. We want the AI to be properly trained that can give expert opinions to decision makers. But in most cases, AI are trained based on information from various sources from the internet, and not all the information is accurate or reliable. So it's very important that for human to be in the loop to make sure that the models are trained properly, or to verify the information suggestions generated by the AI tools and to work with them. So to kind of summarize what I just discussed. It's to have responsible AI to deliver reliable results for decision making. We need to have reliable data. For the back to the crosswalk detection example, we have to carefully prepare the training data set, make sure that it can train a model that can detect crosswalks in a variety of conditions or environments like urban area, suburban area, rural area. So we need to have a really unbiased data set to train a responsible model. And also, we need to continuously model this because we're going to have new data coming in, and there might be unseen scenarios in the previous training data sets. So we need to continuously to update the model, make sure it can recognize all those new and corner cases. And the other one is about redundancy. I think it would be helpful that we have a model or maybe multiple models so they can kind of help each other. We have seen this in our model training. One model can pick up certain features, but not by the other one. So if we have multiple models that can work together, that's another way to ensure that we can generate reliable results. And so that's what I have. Thank you.
Thank you, Professor Xie. That's very useful. And our third question goes to Professor Naranjat. Can you talk about the standard and the validation of a different AI algorithm in urban research? You showed a good example for the fire stations. And can you talk about how do you validate the result and how do you the standard of application? Thank you.
Yes, definitely. So one example you said is right on, like when you're moving fire stations around, the response times that you get have to be calibrated. And a lot of those times, those are like customized response times, especially if you're thinking about fire departments and so on. So calibration, I see it either standard in the sense that we've been applying it in academia for a really long time, using standard machine learning or operations research, whether you're calibrating, testing, validating, and whatsoever. So we apply all of those standard methods, but in implementation, it's a little bit different. And I want to give an example here with implementation that we've been doing right now. And I'll explain it with an example. So what I'm showing here right now is an actual live tool that's being implemented in the Toronto Transit Commission. That's Toronto's transit service that serves the entire city. And we're working with them in delivering a tool that allows them to identify bunching instances. This is when two or more buses are clamped together because there is disturbances in the schedule or whatsoever, and then they remain together for a really long time. And this is very bad for level of service because you were expecting to wait 5 minutes for a bus to come, but because they're bunched together, you're maybe waiting 10 minutes and then two buses come together. So the city and a lot of other transit agencies have high priority to fix this. So what this is showing right now is in real time. This is showing several routes that they've selected in the pilot, so we can pick which routes are going to be implemented. And in real time, it makes recommendations of which bus to hold where and for how long. So this is a vehicle ID, and this gets updated in real time. So you'll see as new data is coming in, this data gets updated. So it shows you which bus to hold where for how long, and basically which bus to hold at which station and for how long. So this is all here. And this is right now the supervisors are using it. So as these recommendations are made, they can zoom in and see what recommendation is being made. So this is like a bunching instance. They can see where these cases are happening. So these two are very close together, so they're considered a bunch. And so this is where I want to talk about validation. Validation is if you just say, this is my AI and this is what I expect to be perfect, in selling it and bring it into practice, there's going to be a lot of hindrances and backlashes. So bringing that human decision-making element into the AI and using that for validation is very important. And the way we've done that is from all these recommendations that we make, the supervisors who talk to the drivers or text them, that's the way that they can communicate the decisions here to the drivers, which they call the operators, is they can either apply a change, and once they do, this is applied, so they click apply and they make the call or make the text, and this way we know that they've applied it, or they can choose to ignore a change. And when they ignore, they can pick a reason for why they ignored that particular change. So we're not relying just on our own validation, and we're getting feedback from the supervisors as they're making these decisions. And as time goes by, what we're able to see through that validation, we're able to generate different kinds of outputs out of this, which will show us basically how they're doing in terms of how many changes they've made. And so if I go here, you can see for today, this is today, you can change any day. For today, we can see that about 206 actions were taken by the supervisors, 34 applied, 172 were not. So for all of those that were not and ignored for whatever reason, we can see what these reasons were. And then we can close the feedback loop and implement models and corrections that are gonna lower the number of ignores that we get. And finally, through that validation that we get through that human usage of the AI, we gain more and more confidence in it. So this is a little bit more niche in terms of validation and how you do it in practice, but the standard methods of doing it, I'm sure we're all very aware of it. So I'll give another much more standard method here is that when that human decision making is not really that involved and you're just doing planning, operations, and it's more decision making rather than that, then, like I said, standard calibration method. So for example, when you add a station somewhere, in this particular one that I was showing, the thickness of the lines, which represents the flow of ridership you see from that station to nearby station, comes from a graph neural network that has been trained and validated. And so standard machine learning techniques have to be applied. And one way to build that confidence even more with the partners that end up using our AI from academia is to show the results of our calibration. How accurate are we in these predictions we make? How good are the optimization results that we're producing? And so if you can bring that down to a level where the user of the AI understands it, that's what builds confidence and pushes the work and collaboration forward.
Thank you, Mahadi. That's a very wonderful discussion, and that's actually a great segue to our second question. We know there's a bias in AI research. How do we ensure a good access and understanding to AI-driven mobility and the smart city system? So I have three small questions. The first one go to Professor Xie. So how do you think we can tackle the algorithm bias in traffic prediction and urban mobility data?
All right, thank you. So I probably will also touch on related factors, not just traffic prediction or mobility. I would say the bias in the outcome or the algorithm sometimes are caused by data sets. So one example is about traffic detection. There are certain modes that are not well represented now. For example, e-bikes. Maybe in your training sample, you can have a lot of bikes, but not e-bikes because it's really difficult to tell the difference between bikes and e-bikes. So such factors may lead to biased data sets. So, and then we won't be able to detect those road users, e-bikes, scooters, or people pushing strollers, without detecting them accurately, reliably, and we won't be able to know the demand for such road users. So that's one point I want to make. Sometimes the biased outputs are because of the insufficient data set. The other one is model drift, something I kind of touched on in the previous answer. So we have new micro mobility devices, new vehicle shapes, and the data set or the data pattern may change, and we also need to update the training data set to reflect that. And the third one is about privacy. So there are applications, for example, they extract a license plate from videos and use that for traffic studies as well as public safety studies. And such information is very useful, but if the if the data lands in the wrong hand, it could be lead to some severe consequences. So in this context, we need to so responsible AI in this context probably should include very strict access control, limited data retention time, and we also need to encrypt the time the data. And set a very clear rules about who can access the data and for what purposes. So being a responsible AI in this context is not just about predicting traffic well. It's also about fairness. Make sure you have a comprehensive data set that can capture all road users, and also about privacy protection, about accountability, and make sure that the sensitive data sets are saved, stored safely, can only be accessed for specific purposes.
Thank you, Professor Xie. That's a very good answer. The second question goes to Professor Naranijad. So that's related to your fire station analysis AI powered. How do you minimize the negative impacts of AI to the marginalized urban communities in the smart city research?
Sure, let me share my screen. Can you see my screen right now, the map again?
Yes, we can.
So I'm going to talk about examples of marginalized communities and equity as a whole, which is a big part of a lot of research that I do because we try to create the relationship or explain the relationship between the cost of doing something and the level of service you achieve from it and how that level of service is distributed between the different people of a population. So this is another example I'm going to show. This is for winter maintenance planning. This is for a city in Ontario in Canada, which has commissioned us to develop this for them. What you're seeing right now is different zones which are in different colors, and each zone has two different types of roads, primaries and secondaries. So primaries are prioritized compared to secondaries, and the way they plow, the way snow plow trucks run is they don't make any left turns, they don't make any U-turns, or they penalize it as much as possible. So what this does is, first of all, I'll show you how it works. There's an optimization engine that allows you to optimize the routing of all the vehicles. So they start from their designated depots, and you can change all of that. They drive to their designated zone, do all the primaries and then the secondaries, and then they go back to where they want it to be. So what this allows us to do and what the city is really interested in is the level of service. How quickly did we do this zone compared to another zone? And what's the level of service that we're providing to these zones, different populations? And is there equity in our level of service in that sense? And so all of that, they can visualize and see what happens in like the statistics that we generate. So the levels of service, the way they're defined in cities is you have to plow a zone a certain time after a storm happens. So these ones, we can see the completion time of the different zones, and we can see where the standards are and whether some of the zones are surpassing those limits that we defined in terms of level of service, or they are within the boundaries. So we can identify those zones, we can make changes in the boundaries of those zones and see how the changes would be affected. So for example, one of the things we can do is we can add new zones, delete new zones, or we can modify the boundaries of a zone. So I'm going to pick a zone here, zone 10, and when I come here, I can check this, and I can play around with the boundaries of this zone, make it larger, make it smaller, rerun the optimization, and see how the route is going to look. So prior to this, a lot of this is done by consultancy. Consultancies come, they do it just once for the city, and then the city relies on it for the next 5 years. They have very limited capability in terms of how they dynamically change this year to year. So what we try to do with our partners in this case and in other cities that have interest in this is to give them that power of decision making, power of planning and analysis. The other examples, like you said, in terms of equity and the bike sharing examples that I gave you in master plans, when you look at it, these are three criteria that are very important: population, which is accessibility, equity and transit integration. And these are weights that sum to 100. In a master plan, this equity element is critical because, it was explained, lots of cities have interest in providing accessibility to public transportation in those cities. So you can play around with these weights. And so, if, for example, if you have a higher weight on equity compared to transit integration, you can see how this heat map is going to look and what the new location of the stations is going to be. So they're more in the north than they were in the south. So this equity, typically equity layers are provided to us by cities. And lastly, if you're looking at, for example, these are just examples of levels of service and the equity that you try to provide in that sense. So in this one, for example, if you're looking at fire station planning, you're seeing here the load that each of these 5 stations would get. And the way you would be able to manipulate that load is to play around with the boundaries of these zones. And once you do that, you can make one load smaller, you can make one load larger, and you can balance off the equity in that sense. So equity and in the level of service that we provide has been a major theme in what we do, and there's always an element for it.
Thank you, Professor Naranjad. And the third question goes to Professor Claudia. Can you talk about the importance of data sharing, especially in terms of private-public relationship in data sharing in AI for smart city research?
Yeah, sure. So for us, one of the key concerns that we have with the system that we are developing currently on traffic safety is the fact that a lot of the information that are gonna be, I mean, I'm talking mainly about the use case that we have, but a lot of crimes that we're gonna have to deal with are related to privacy intrusion problems just based on the fact that we are trying to predict actions. So for example, the models that are going to be used to predict actions of users are gonna have internal states. And these internal states can be potentially privacy intrusive. So, for example, if you want to predict the actions of a driver, the future actions of the driver may depend on the state, and you might analyze, for example, if you use the AR headset or the AR glasses that we are developing, that we're working with. So if you see, for example, that the person has some weird eye pattern motion and other factors, you can, for example, guess that the person has been drunk, for example, and that has, of course, an action. That's a very important model parameter if you want to predict the actions of a person. However, you know that you cannot just report that information. It's usually privacy intrusive and could fall into all the wrong hands. So we have this, for example, this example. So you have, of course, you could have someone that is drunk, but you could also have someone that has a certain particular disease that is not declared yet, or other factors, and this is actually extremely sensitive in the end. So we are really dealing with this problem of data sharing and essentially segregating the data as much as possible. Our future direction on this topic is to do everything on the edge, so that basically there is no cloud information transferred, so that all the sensitive parameters stay within the system. I think that's the only way to guarantee that people will have enough confidence and trust in the system. However, this makes it more complicated, for example, to analyze the behavior of the algorithms or to redevelop things in the future. So this also has some limitation, but I think this is a critical topic for anything related to safety or prediction.
Thank you, Professor Claudia. Our last open question focuses on the future of smart city, specifically how the responsible AI policy or procedure can be integrated in the future smart city development. The first sub-question goes to Professor Naranjad. Based on your previous experience, how do we integrate responsible AI principles when work with the city in their procurement process or in their planning, development, engineering process?
That's a great question. So, in terms of how we build trust and where the direction is going, trust, I believe, comes. It's difficult, at least in terms of what we're doing from academia, because a lot of, at least because you mentioned cities in particular, a lot of cities, North American cities, are very accustomed to the culture of writing RFPs and then having some consultancies come bid on them. And the big change that I see is this, the big consultancy on analytics is going to change because it's not very sustainable. Big consultancy is not very powerful in building on previous knowledge because they work on a business model of let's get a project and let's do it with the minimum cost possible. So I think a lot of public sector is starting to realize that the big consultancy model is not necessarily sustainable because you see them every 3 to 5 years or every time you need them. Whereas a lot of cities already have a lot of resources at their disposal where they can do a lot of the analysis themselves, but they just need to have the right tools and the right AI at their disposal so they can do it. So I see that the interactivity, what if scenario planning as something that would be very attractive to the public sector and the private sector, because both of them, there's a lot of data in both sectors, but not a lot of information. Especially if you look at cities. Cities now have data on pretty much everything. But how do you convert that data into decision support systems that are built on AI is something that's missing. And I think academia can have a huge role here because of that reason that we said. If you look at like who's working most with the public sector, cities in particular, it's big consultancy. And for those issues, academia has a lot more time and patience to build things rather than just doing projects. And so what I've come to see is I've come to see several people in the public sector, which I call like AI champions. These are people that have an understanding of AI. They don't have a full grasp of it, but they appreciate that there's some value behind it. And those people are rare, but once you find them, I've come to realize they will be a huge advocate for you, but it requires to build that confidence with those champions first. But that person will be the person that will be your interpreter with the agency that you're working with, so they can bring problems to you and they can help you customize solutions for them. So finding those AI champions is tricky, but extremely valuable. And that's kind of where I see this direction going with AI coming into the public sector. The private sector, the tech sector, companies like Amazon, Lyft, they're already scouting for what state-of-the-art AI and who's doing what, who can bring that skill set into that company and what the value will be. But the public sector, for natural reasons, in North America is behind. And those AI champions are the ones that I think will be the entrance points into cities and municipalities and transit agencies.
Thank you so much, Professor Naranjit. We have 2 minutes, so I will combine some audience question with my question together. So audience ask how AI can be used to address urban challenges like pollution, flood, resources loss, energy, water, and so on, so on. My question to Professor Xie is, how do you think in the integration of a different discipline working together can moving forward for smart city development? And for Professor Claudia, how do you think technology-wise, emerging technology like a robot and a digital twin can be used to address above questions? So we'll give the first answer to Professor Xie. You can start.
Well, in the interest of time, I will keep it brief. I think in the future, we probably can treat AI as a very knowledgeable and also a very smart co-worker. We probably should not depend entirely on AI, ask AI to give a suggestion, because AI is trained on all sorts of data, could be correct opinions or incorrect opinions. To solve the questions mentioned and the problems mentioned in the question, it's very comprehensive, as you know. So we can work with AI and listen to AI, but we should rely entirely on AI to solve those very complex problems. I'm sorry, I don't have a direct answer for that. All right.
Thank you, Professor Xie. Professor Claudia.
On my side, I think that we will have many emerging directions. I mean, humanoid robots, wearable, etc. So much more data, much better actuators, much better quality in everything. We also have much better ability to process, for example, video data compared to what we could do 10 years ago. So clearly, AI helps a lot in processing this massive amount of data. But I'm also thinking that we shouldn't try to AI-ify every single thing. There are some things that are inherently not AI problems that won't be solved by AI. This said, we have to look at it as a smart user, as essentially something that can allow us to do things that we couldn't do in the past. But this is not completely the panacea. It will not solve every single thing.
Thank you, Professor Clauder. In term of time, let me close out today's session. So today we have a wonderful discussion about responsible AI application in smart city area. We have three distinguished professors, Professor Clauder, Professor Naranjad, and Professor Xie from the different part of the country to talk about their own research. And we believe when we work together, we will be able to tackle many smart city problem. Let me share the screen so we will have a second session tomorrow for you to attend. So tomorrow we will have a second part of a responsible AI symposium, start from 9. Then we will have three different panels. Then in the end, our Go System Chair, Professor Ken Fleshman, will give us a closing remark on the power of collaboration, forging partnership, and AI. Thank you again for attending and have a wonderful weekend.